And do I have my screen? I almost do. And can you see it? I have no clue. Can you see the screen?
It's loading. Yeah, there it is.
Okay, so what I want to do is advance it or yeah, flip it to the next one, put some lines on and we're ready to roll. Maybe not. Okay. Come on. Yeah, great. Okay. Okay, so now do I want to sit? I think I want to sit. Sometimes I stand. Let's try sitting here. So let me move this down. That may be better for me at this point. Perfect. Okay, I assume we're doing problems from the sample test, but it's not restricted to that, so I will take request. But as I say, I expect most of them to be coming from the sample test, but maybe not all of them. What do you want to see?
The sample test is good with me.
Okay, I think I did 1A. Should we just pick it up from 1B? I could do 1A.
Sure, that's fine.
Yeah.
Yeah.
I
Why don't
would
we start?
Professor,
Go ahead.
is the final only gonna be from this sample exam, or are you gonna throw in some of the previous stuff too?
Not the previous stuff, but this test doesn't cover everything we've been doing. So tomorrow I was going to give you a problem or two that dealt with some things that we've done. So for example, finding stationary distribution for a Markov process. Now, maybe that's in here somewhere. I don't know. I'll have to look more closely. But I do intend to give you a couple more problems tomorrow in class that would be representative of what the test will be. But to answer your question, most of the material will be from chapter 3, almost all of it actually. So the test on the final doesn't really go back to, throughout the whole semester, just the last third mainly.
So it's more so everything after the second exam.
Correct. That's correct. Okay, well, I mean, I could list things in order here. Maybe that's a way to do it here. So there's 1B, there's 2. This is all sample test material. There is 3, but I think that's not for us. There's 4, which would be for us. 4 and 5, I think. And 6A is okay. 6B we didn't get to. And let me see, is there more? That's about it. Did I give you anything else? I don't recall. So if there's more, let me know. Okay, so let's just poll you here. I mean, this will keep us busy for a bit. So I'll probably do it in order of demand. How many people want to see 1B?
Wait, Professor, I don't think I have question 6.
You don't think you have question 6?
I also don't see it.
Oh, okay. Well, it's something that I decided, I guess, not to send you. But 6 is quick. So it basically asks you to define the queues in the Markov process and to give the properties they have. So yeah, I don't think I sent that to you, but when I look at it now, it's a problem that could be there. So it's only 6A, by the way, I'm talking about. There's another part of 6 that doesn't apply to you at all. Yeah. So the part that does apply to you would be define the queues and give their properties. Okay. So, but let me start with 1B. How many people want to see 1B? Give me a thumbs up or a sign that you want to see it. I've got 1, 2, 3, 4, 5. Oh, now I've got a lot more. Okay. So 1B is a yes with a lot of hands. What about 2? How many want to see 2? So far, I've got 3 people, 4. Okay, it almost looks like the same group. Let's just keep going. How many people want to see 4? Yeah, I think I've seen enough. Let's just do them all in order because it doesn't look like there's one that has 10 and the other just has 1 or something. So let's just go through them. All right, so let me go back to my share of the screen. Back to these. Let's start one. Let's do 1B. So 1B gives you the following diagram. It gives you a 3-state Markov chain. And the chain looks like this. It has 0 and it has 1 and it has 2 in this order. And the rates between here and here, this is 2, this is 1, this one is 2, and this one is 3. So this is clearly a Markov process. Why? Because it doesn't have probabilities. It has rates, and it says determine P of t, and P of t has 9 entries. 0, 0, 0, 1 of t, 0, 2 of t, 1, 0 of t, 1, 1 of t, 1, 2 of t, 2, 1 of t, 2, 2 of t, and 2, 3 of t. So the question is to determine these 9 transition probability functions, and that's it. It's really short and sweet, but it's not short and sweet to do, I don't think. I think it's going to take us some time. If we look at these, though, it does give us some indication of how to do shortcuts here. So, for instance, you can see that 2 leads to 0 and 1, but if you're at 0 or 1, there's no way to get to 2, just from the picture, right? There are no arrows going from 0 or 1 to 2. So a way to think of this would be that 2 is transient. Once you leave, you never come back, and you will leave. There's eventually, and what, 0 and 1 are recurrent. How does that help us? Well, that gives us some of these really quickly. Well, first of all, this is labeled wrong. Should be 0, 1, 0, 2. That's all right. 2, it should have been 2, 0. My bad. 2, 1, and what? 2, 2. Better. Okay. Well, you can see from the picture that you can't get from 0 to 2. There's no arrow leading that way. So going from 0 to 2 will be 0. Just by looking at the transition rate diagram. And similarly, you can't go from 1 to 2. You can go from 1 to 0, You could stay at 1 for a little while, but you really can't get to 2. So that's also 1 to 2 is also 0. Let me see. Well, that helps a little bit. There were 9, now we're down to 7. Is there anything else we can say for sure? You can't get from 0 or 1 to 2. It looks like you can go from 1 to 1 and 1 to 0 and so forth. Or what about 2? From 2, well, it looks like you can go anywhere. Okay, so I think that saved us these 2. But that helps. Does everyone see why these are both 0? Because you really can't go from 0 to 2 or 1 to 2. There's no arrows doing that. So I want to, and I might as well. I'll just erase these if it lets me. And these are both 0. Now we have different ways to do this, but one thing is noticeable. If you knew this one, then you know this one, because these 2 add up to 1. And similarly on the second row. So once you know one of the 2 entries on the second row, you know the other one, because together all the rows, everything on that row adds up to 1. P of t is stochastic. Okay, so that's useful. Let's see. Let's see if we can do it as we were doing the recent stuff. So the recent stuff was, yeah, let's see if that's even going to work. Yeah, I think I can get lazy and do this sort of in a fast way. If you look at the transitions between 0 and 1, they're just back and forth, and you can't go anywhere else. So that looks like a sub-Markov process. Just look at this thing from 0 to 1. You're going here with rate 2. You're going here with rate 1. And you can't go anywhere else because there are no arrows that lead away, as I've already said. So that should give us what? That should give us everything for this. In fact, let me see if I can save a little time here. So if you're just going back and forth for a Markov process on a 2-state Markov process, we've done that a variety of ways. And
Professor,
so, yeah, question.
I don't know if this is making it easier, but wouldn't P22 also be 0?
I don't think so, because, I mean, if you start at 2, you may stay there for a little while. Okay, there is an arrow going back. So I don't think that'll be 0. But I appreciate the help, and maybe I'll reconsider that later. Let's put that one off for the moment. So I'm trying to save time in a different place. The 2-state Markov process is done on page 92 and 93. And it gives you this. And perhaps this is even worth memorizing, I suppose. If you just have something that looks like this, where this is lambda and this is mu. On page 93, for example, they tell you the probability of going from 0 to 0 is mu over lambda plus mu plus lambda over lambda plus mu. e to the what? Minus lambda plus mu t. And by the way, not only does it appear on page 93, it also appears as part A on this problem. So if you already had to do the two-state Markov process to do 1A. So it seems very reasonable that we should be able to use that result to do 1B as well. So I'm suggesting these are known. This is known. And if you flip the page at 93, you'll get, well, why don't I just do 0, 0 and 1, 0, and then the other two will just be 1 minus these. So 1, 0 t on page 94 is mu over lambda plus mu minus mu over lambda plus mu e to the minus lambda plus mu t. Okay, and so if you know that, you can apply that to this subchain or subprocess actually. And what would P00 be? P00t in this case would be, well, lambda is 2 and mu is 1. So the sum on the bottom would be 3. And the mu is 1, so it'd be 1/3 plus what? 2/3 e to the minus 3t. That would be this one. And the other one, which was 1, 0, would be mu over lambda plus mu, but lambda plus mu here is 3 again. And mu is 2. Well, mu is 1, sorry. Minus this time over 3 still, mu is still 1, e to the minus 3t. So I'm getting this simply from what we've done before, either in part 1A of this problem. Well, part 1A, let me just make sure. Yeah, part 1A has the same rates, 2 and 1, so it looks like a setup. So if you've done 1A, and we actually did the other day, we know both of these. And if you know both of those, from what I said before, the rows here add up to 1. So we can simply say we know the other two. So P01, for instance, P01 would be 1 minus P00. And since you know this, you can just subtract that off. And P11 would be equal to 1 minus P10. And so knowing each of these, subtract them from 1, you should get the other ones. So we're making pretty quick progress here. So far we have this guy, this guy, this guy, this guy, this guy, and this. 2 of them were just by noticing you couldn't get back. You couldn't get back to 2 from 0 or 1, so that came quickly. And then these 4 came from realizing that when you were on this process, part of the sub-process right here, you can't get to 2. So that would really be just making transitions on this. And that's exactly what we did the other day when we did 1A. So are we okay so far? So what I don't have so far, or what remains to worry about, would be these guys. Okay. Okay, so how to get those guys? Well, I guess there are different ways to do that one. Let's see. And I'm trying to think what would be the easiest way. Well, why don't we try what we were doing the other day, and if it doesn't work out, then we'll go back to solving differential equations. So there's different approaches here. So what we had the other day was this. If you wanted to find PT, you could represent it in this form. Find the eigenvalues. Suppose the eigenvalues are omega 1, omega 2, and omega 3. And suppose they're distinct. If they actually are distinct, then there's a solution that looks like this. Okay. That's the method that we've been talking about this week. So that's what comes to mind at this moment. And from what I've said before, so that means we need to find the eigenvalues of the Q matrix. So what would be the Q matrix here? You can form the Q matrix this way. From 0 to 1 is 2. And you can't go from 0 to 2. So this would be -2 because the rows add up to 0. From 1 to 0 is 1. And you can't go from 1 to 2. So 1 back to 1 would be a -1 because again, the rows add up. And then from 2, you can go, oh, I lost something here. This was -2, I believe. From 2, I can go to 0 with rate 3, or I can go to 1 with rate 2. And then this would be 5, -5, again, because the rows all add up. Okay, so I think this method would work fine if we know the eigenvalues. And so let me throw that to you. Can you put this on your calculator and come back, tell me what the eigenvalues were? We were doing that the other day. I know one of the eigenvalues is 0. So if I call that one omega 3, then this would just be 0 times this would just get rid of that. So suppose I assume that 0 is the omega 3. Can you give me the other two eigenvalues? So that's putting it on you to put this on your calculator and hit the eigenvalue button and hopefully come back with all the eigenvalues. Let me know when you're able to do that, or if you're able to do that. It's good practice.
I think I have them.
Good. What do you got?
I got 0, -3, -5.
Okay, 0, -3, -5. I don't think it really matters so much what order we put them in, but I have called this one 0. Okay, who got that? Was that Hugo?
Yeah.
Okay, let me just make sure someone else could confirm it. Can someone else agree that Hugo's right?
Yeah, I got the same thing.
Okay, cool. Well, the good news is that means these are distinct. So that means the method that we were doing in class the other day should work. Why don't we just go for it? So why don't we put this one to be -3? I'll put that right on here. And this one would be -5. Again, if you order it in a different way, you should still get the same right answer, perhaps just coming out in a different order. Okay, so that's good. Now what do we need? We need to know what the A's are, right? But and how did we do that? We first of all, let T be 0. So P of 0, then what does P become? If you set 0 in here by our initial values, you get the what? The identity matrix. So this becomes the identity matrix. And when you put t equals 0 here, you'll just get a1 plus a2 plus a3. So that's one equation and 3 unknowns. We need a couple more. The next one that we did the other day was to take the derivative of this equation. If you take the derivative of that equation, how do you do that? You take derivatives term by term. And yeah, question?
Yes, when it comes to the eigenvalues, it doesn't matter what order you put them in.
No, just
Okay.
as long as you're consistent and don't start putting them in different orders as you go along. Okay.
All right, sounds
But
good.
yeah.
Thank you.
Yeah, it should affect the final answer, even though, it'll look a little different along the way, but in the end, it should turn out the same. So when you take derivatives here, you get a1, the derivative of this is itself times -3. And then it would be a2 that, remember, a's don't have any time variables in it. So the only t appears in the exponential function. And the derivative one is 0 because it doesn't depend on time, just what I was saying. So you might as well leave it off. Okay, and after you get this, then you can just let t be 0. That's a let t be 0. This turns into q by definition. We already know what that is. And this one, when you put t equals 0, you just get -5a1. And here, whoa, I did this wrong. That should have been -3. You can't tell your 3 from your 5. That's going to hurt you. -3. That's better. And then this one, when you put t equals 0, you do get the -5. So what are we trying to come up with? We're trying to come up with 3 equations and 3 unknowns. We're 2/3 of the way done. We've got 2 equations in the 3 unknowns, a1, a2, and a3. Any questions thus far? Cool. To get the next one, that's probably the hardest one. You need to differentiate this one more time. Hang on one second. I think I'm getting called. Hold on, please. Someone just called. Okay. Okay. Yeah. Yeah, that was pretty funny. I thought it was my wife, and turns out she's in the house. Okay, so she wasn't calling at all. Okay, so what am I doing? I'm taking a second derivative of this thing. And that's just going to give you what? Something that looks like a1. The exponential still lives there. Another -3 will come out. So -3 times -3 is 9. And then this will give you the a2. The derivative of the exponential is itself, with another -5 coming out. So that'll give you 25. Okay, now if you let t in this be 0, on the right side, you're just going to get 9a1 plus 25a2. Then a little harder to remember what's going on over here, but what you need to remember is the forward equation or backward equations. So let's do the forward. I think we did that the other day. This is, well, actually, that's the backward equation, I think. It shouldn't matter. And when you differentiate this again, you do the product rule and you end up with something that looks like this. And then this, putting in this again, gives you what? P of t q squared. So when you set t equal to 0 in here, you get q squared this time. This should look familiar because it's more or less what we had the other day. So now the 3 box equations are 3 equations and 3 unknowns, and we should be able to determine what all the a's are. So let's do that. What's the easiest way? I'm not sure. Well, we can solve for, it's probably an easier way if I look at this in a second. Well, let me just do it one way. We can solve for A2 from this one. So this equation here implies that q squared minus 9a1 is equal to 25a2. So what does that mean? If I divide everything through by 25, q squared minus 9a1 would be equal to a2. So I have a2 in terms of q, but q is known. That's up here somewhere. There it is, up there. So I have basically a2 in terms of a1. And if I put that into here, I'll be able to find out what a1 is, I guess. So let's do that. So substitute this. And as I said, there are many ways to do this. This is just one way into here. So you'll have q is equal to minus 3a1 minus 5a2, but a2 is all of this stuff. 1/25 q squared minus 9a1. So I've just substituted that in there. And now I get this equation, which only involves a1 and q's, but the q's are known. So this is minus 3a1. This times this is just minus 1/5, I guess, times q squared minus 9a1. And on the left side, that all equals to q. Okay, so if I bring the stuff involving q to one side, I already have q over here. And if I bring this over, that'll be a 1/5 q squared. And then what's left on the right side would be minus 3a1. And then it looks like minus times minus is plus 9/5 a1, apparently. But so we can factor out the a1, so it's minus 3 plus 9/5 all times a1. And common denominator would be, I guess, fifths. So this would be 9/5 minus what, 15/5? So that would be minus 6/5 a1. Make sure I didn't make a mistake there. Yeah, minus 15/5 is right. And that plus 9, you get minus 6/5. So that's fine. So now that, look at the ends, that equals this. So if you want to know what a1 is, a1 would just be multiply both sides by minus 6/5. Minus 6/5 will get you a1 on this side. And over here, it'll get you this. So we have a1. If I did it right, let's see. A1 is, oh, I think I should have flipped that over, shouldn't I? Sorry. So I'm solving for a1. So I multiply both sides by what? Minus 5/6. So this should have been flipped over. Minus 5/6. I think otherwise I'm okay. That's A1. But then we also had an equation for A2 in terms of A1. That was this one. So we also know that A2 is now 1/25 q squared minus 9A1, but this is A1. Okay, so replace all this by this, and that would be minus 5/6 q plus what, 1/5 q squared. Let's make sure I did that right. So from here, A2 is 1/25 q squared minus 9A1. Yeah, come on in.
Sorry to interrupt you.
Yeah.
I need your help getting something down.
Okay, give me 1 minute, okay?
Okay, just one, because I'm trying to leave.
Okay,
Another place.
sure. All right, so let me just,
Sorry. to interrupt you.
let me return this real quick. I'll come back. So, yeah. Where- Okay, I'm back. I think it was in the process of making sure I did A2 correctly. So let me double check on that. A2 is 1/25 q squared, check so far, minus 9, there's the minus 9 times A1. And all I have to do is put in A1. A1 is negative 5/6 q plus 1/5 q squared. So this looks right. If we want to simplify it a little further, it looks like 1/25 q squared. And then this, oh goodness, this looks like 3/2 times 15. So that's what? Yeah, got to be careful. So there's the 1/25 multiplying everything through. And then this became, what did I just say? 3/2 times 5, I believe. And then all of that is times what? Q plus 1/5 q squared. But there's enough fractions there to make them want to go back and do it again. 1/25 is right. 3/2 is right. The minus 5 should be there. But the minuses combined to give me a plus, so I think I already did that. So I think this is all okay. Let's go a little further. This is 1/25 q squared. Here you have 5 into this, so that would be what, 3/10? No. Yeah, 3/10 times q, so might as well multiply it through. Plus 3/10 times this, so that's what? 3/50 times q squared. Again, you can check my arithmetic. Hopefully I'm okay. I'm looking it over again. 3/10 looks good for this. This times this, so this was 3/10. 3/10 times a fifth is 3/50. Yeah, I think it's okay. And if you add these guys together, this is 2/50 and 3/50, so that's 5/50. 5/50 is the same as 1/10 q squared plus 3/10 q. So that appears to be A2. Okay, and the last one we can get using the first equation. So if you add up A1 and A2 and A3, you get the identity. So that means what? A3 is minus the sum of the other two. 1 minus the sum. So 1 minus A1 minus A2. A1 is this, A2 is that. And so you can do this to get A3. So that would be 1 minus all this, which just changes the sign. And then minus A2, so that would be minus all of this stuff. Okay. So we're pretty much done. Why? Because we have all the A's now. We can figure out what they are more explicitly. We already know what Q is. Q is this. And so you either can multiply this by itself by hand, or you could do it on the calculator. You could, if you already have Q there, you could just do Q raised to the second power. And that will give you Q and Q squared. And if you put those into all of these things, you'll be able to find out what A1 is, because once you know Q and Q squared, you can do this. And once you know Q and Q squared, you could do this. And the same thing over here. This is all in terms of Q and Q squared. So I think I'm going to beg off and doing the procedure, because I think you know how to do that anyway. Once you get all these things, then the matrix P of T is given by this up here. So once you know A1, A2, A3, you can put A1 in here, A2 in here, and A3, whatever it turns out to be in here. And then if you wanted the remaining three values, these are the three that you don't know yet, you can pick them off just by doing what this says. It would be whatever A1 is times this function of T, plus A2, this function of T. These are all 3 by 3 matrices. So pick off the entries from the last row of each one of them, and that would give you each of these. I could do one of them if you think it's worth the while. Let me know. If you want me to, if it's pretty clear how to get the answer from here, then I'll move along. If you think you still need to see a little more, let me know. I'm good either way.
I think seeing one of them will be helpful.
Okay, one of them. Cool. Let's do one. So let's go for P20 then, right? The first one. So this is the one I'm going to try to get. And where is it coming from? It's coming from this equation here. So what I would need to do to get, maybe it's easier just to draw that again. To get the P of T matrix looks like 0, 0 is up here, 0, 1 is here, 0, 2 is here, 1, 0 is here, 1, 1 is here, and 1, 2 is here. And what I'm going for, P22, is down here. And then the other ones are P, well, that's not P, it's P20, sorry. Making sure I'm doing the other ones right. Yeah, I think it's okay. P20, P21, and P22. Okay, so what I need to get this guy, I need to find out the matrix A1. So I'll just write it this way. So it's the matrix A1 times e to the, what is it, minus 5t? Make sure I got the order right. Nope, minus 3t. Sorry about that. And A2 e to the minus 5t. And then A3. Okay, so, but if you expand this one, this is a 3 by 3 matrix. And the entry I want is the same entry, this guy. And then whatever is in there, that's some constant, that's going to get multiplied by e to the minus 3t. And then I do the same for the other two. I pick the same entry here, multiply it by e to the minus 5t. And then finally, look for the same corner entry here. So what I need to know the corner entries of A1, A2, and A3. And I mean the left bottom corner entry of each of those. Let's see if we can give these names. I'm trying to think of, well, maybe I can just find them. That might just be easier. So why don't we do A1? I'll let you help me. You know what Q is. Q is equal to this matrix here. So take Q, and you need to find Q squared. Probably safer, maybe. It depends. If you have Q on the calculator already, let's just do it together. What is Q squared? So I don't care whether you do it by hand or if you do it on the calculator, whatever way, whoever gets it first, give me your answer, and then we'll check it with someone else's. So when you're first row, go for it.
I think I got 6, negative 6, 0.
I heard minus 6, 0. Was the first one 6?
Yeah.
Cool. What's the next row?
And I got negative 3, 3, 0.
Okay.
And then negative 19, negative 6, and 25.
How did you do it? By the calculator or by hand?
I did it by the calculator, so I've been saving my matrices into a variable, so I just squared it.
Cool. Well, let's see if someone else agrees. So that's Millie's Q squared. Does anyone else agree?
I got the same thing.
Perfect. Okay. So now we have Q squared and we have Q. So now that should help us get what we want down here. Because we want to know, what do we want to know? We want to know the lower left-hand entry of, what was I just describing, if I can find it again. Yeah, down here. To get 2, 0, I want the lower left-hand entry of this matrix times this, the lower left-hand entry of this matrix times that, and then just the lower left-hand entry of this, and there is nothing to times it by. So we need to find A1, and A1 is this. And the good news is we know what Q is, and we know what this one is. So we should be able to find A1. Now, we can do that. probably, since you want to find them all, it probably makes sense to do them all. So why don't I just ask you to tell me what A1 turns out to be? I'll let you help me. But again, we already know Q. And Millie just gave us Q squared. So can you tell me when you take 1/5 of this, how do you take 1/5 of this matrix? You just take 1/5 of each entry of it, add it to the Q matrix, and then multiply that everywhere entry by -5, 6. So you know what? I'll be happy if you just tell me the lower left-hand corner of it, because that's all I really need. When you do this process with Q and Q squared, what do you get for the lower left-hand entry?
I think I got 2/3.
Did I hear 10/3? Is that what you
Oh.
said?
2/3.
2/3. Okay, now let's wait and see if someone else can check that. It shouldn't be too bad because you already know Q and you already know Q squared, right? But there's still some arithmetic here to deal with. Anyone agree with Millie's 2/3? I can try it by hand here while we're waiting.
I got 2/3
Oh, okay. So
for the lower left.
for the lower left corner, that's all I'm looking for at the moment.
Yeah.
What I was about to do is take the lower left-hand corner of this and the lower left-hand corner of this, take 1/5 of this, add it to this, and then multiply the sum by this. But if you're getting 2/3, let me go with that. So that's this part. 2/3. Now we do the same thing over here. So the contribution for the, so far, what do we have? P20T would be 2/3 times e to the -3t plus this one times this, and I don't know this one yet. So I need your assistance for A2, but we do have A2 right here. So since you know Q and Q squared, and you take 1/2 of this guy and 3/10 of this guy and add it together, you'll get a 3x3 matrix. But for the moment, all I need is that lower left-hand entry again. Whoever has it, please volunteer it, and then we'll corroborate it. Now the sad truth, you got it.
Yeah, I think I got -27/5, maybe. Oh wait,
Okay.
I think is it 1/10 Q squared? Or I think I have it backwards.
It's 1/10 Q squared plus 3/10 Q, assuming I did this correctly.
Then I got -1.
Oh, so you're changing your answer to -1.
Yeah, I think I did it. I accidentally did 1/10 Q plus 3/10 Q squared.
Yeah, now you got me worried about my arithmetic here. Let me see if I'm doing this right. This is 250. That's 550. That's 110.
No, I think it was me. I looked at it wrong.
Yeah, I think it's -1. I mean, I think my arithmetic is right, and assuming yours is, it's -1. But let's let someone else confirm it. So figure out the lower left-hand corner of the matrix A2. Millie has -1. If you have a disagreement, then we have a conversation. Okay.
I agree. It's -1.
-1, cool, okay. So if it's -1, let's put that in here. And so the answer so far looks like 2/3 e to the -3t, and now it looks like negative. That's coming -1 here, coming e to the -5t. And the one that's left is just the lower left-hand entry of this, and there's nothing to multiply it. So it's just whatever that turns out to be. And where is that? That's A3, and A3 was this. So I need someone again to take Q and Q squared and multiply Q by -3/10 and multiply Q squared by -1/10. And when you do that, you'll have A3. And all I really need is the lower left-hand corner. That shouldn't be too bad. I think I could almost do that by hand if I know.
I got one.
You know, I got one. All
Yeah.
right, so you guys are already ahead of me. Let me just go with you. One was Hugo this time, right?
Yeah.
And someone want to confirm or disagree?
I got the same thing.
Wonderful. Okay, so it's 1 and there's nothing to multiply it by, so it's just +1. So that's how you would find this guy. Now, when you're all done finding all of these guys, I guess so far we've already had most of them, right? Let's go back up to where we already knew everything except for the bottom row. And now we just did this one. To be completely done, you'd only have to do one of the following two, because again, once you find one, this one minus the sum of the other two would give you the third one. So you're almost done with all of this. And you can do the last one if you wanted to go for the middle entry instead of the far left entry. You could just do what we did again for each of these matrices, but this time picking off this entry. But when you pick off that entry, don't forget to multiply it by the appropriate power of exponential business back up here. So 2 times you'd multiply it by an exponential function, and over here you would just get a constant. Okay, once you get all of those things, if you have time and patience, you can actually put them into the forward or backward equations and check that they work. I don't want to do that because I think we have other things to do that would take precedence, but it is possible to check. Does everyone see now how to get the entries on the last row? I got one of, together we got one of them, this one. Another way to check is, this has got to be a probability, right? So if you don't have time to check it quickly, you could just put in maybe value. So for example, if t is 0, if t is 0, then you're going from 2 to 0 in no time at all. That should get you 0. I'm not sure it is. Let's see. If t were 0, oh, these are gone. The ones cancel, and it's getting us 2/3. Whoops, something's wrong. Let me see. Okay, so what am I checking? I'm checking the initial values, right? So I'm checking 2 to 0 in time t, and I'm letting t be 0. So that would be going from 2 to 0 in no time at all. And we would say if there's no time to go there at all, it should be what? It should be 0. But that's not what we're getting. Because this is 2/3 minus the third, minus 1 plus 1, we're getting 2/3. So something's off. Interesting. Okay, let's check it again. So we're doing this one, but it's not coming out. So we're coming out with, we're using this. And we're picking off the lower left-hand entry carefully each time. And what did we get? We got 2/3 for a 1, is that right? I believe so. A -1 for a 2. So let's make sure I combine this right. 2/3 for a 1. And did A1 have? Yeah, 2/3 times this one. What was A2? Where is A2 in this scheme? -1, right? So that's -1 times e to the -5t. And then +1. All right, so let's recheck these because it should, the initial value going from 2 to 0 in no time at all. Our initial value was 0, right? So it should agree with that. But when I'm putting in zeros here, I'm getting 2/3, I'm getting -1, and I'm getting 1. I'm getting 2/3 is the answer. So something's off. That's why I pasted check. Let's see if we did it right. Now, it could be two things. It could be my A's are off, which is more serious. Or it could be that, you know, when you did the calculations, you got something off. Where should we start? Does everyone see the problem? The problem is when I put in t equals 0, this didn't give me 0, gave me 2/3. So let me just recheck the work that we just did, hoping that everything there is before there is okay. So we would look at A1. Where is A1 in the scheme? A1 was here. Okay, so according to this, we look at Q. And where was Q squared? Okay, here's we got everything here. So we're looking at Q, this entry. And Q squared was this entry. And what do we do with those two entries? When we're doing A1, we're taking 1/5 of Q squared and adding it to Q. So 1/5 of this would be 19/5. And adding it to Q would be 3. And where's A1 again? So that's what we did. And then we got to multiply it by -5/6. So we have to take this and multiply it by -5/6. Okay, so -19/5. And this would be 5 top and bottom. That would be 15/5. -5/6. So when you add these, you get -4/5 times -5/6. The 5 cancels and you get -2/3. Is that what people gave me? I don't remember. Yep. Oh. Did I drop a sign? Let's see, is it -2/3 or is it +2/3? Let's check all this stuff. -19. And then, so we've got to remember what A1 is about. A1 is about this. Take Q and add 1/5 Q squared. Take Q and add 1/5 of Q squared. So that's this. That's -19/5 plus 15/5. So that's -4/5. And then multiply it by what? -5/6. So that should have been -5/6. So that's my mistake. So that's the 5s canceling. 2/3 looks right. Okay. So the 2/3 looks okay. Where was the 2/3? Right here. So that one looks fine. And we multiply that times what? E to the -3t. So we're a good bit shape there. What about A2? A2, where was that done? Over here. So what do? We take 3/10 of Q and add it to 1/10 of Q squared. 3/10 of Q. Make sure I'm doing that right. Yeah, 3/10 of Q. So that would be 3/10 of this. That would be 9/10. So that's 9/10. And then 1/10 of Q squared. Q squared was this. 1/10 of that minus 19/10. It's 19/10. So what does that give us? That just gives us, first time through, it just gives us what? Minus 9/10. Let's check that one again. So we need to do 3/10 of Q in the lower corner. 3/10 of Q. So that's 3 times a tenth. So that's 3/10. That part is fine. Where is it? 3/10 of Q. And what was there? It was 3. So that's 9/10. That's correct. And then 1/10 of Q squared. Q squared is this. 1/10 of that is minus 19/10. Minus 19/10 plus 9/10 is minus 10/10, which is -1, which is fine. So there's the -1. Okay, so far so good. And now what's the last one? The last one's A3, I guess. Yep, A3, and we just picked the last entry of A3. So what's A3? A3 was this. Okay. I'm trying to see what I was doing here even. Oh, I guess this turned out just to be this stuff. I'm not sure. So minus 3/10 of Q, but that was 1/10. There was what in there? Q had 3. Is this all part of it or not? I'm getting mixed up. Let's see. Oh, this must have been A1 and this must have been A2. So it's more complicated than it first appears. Where did we do that calculation? I guess I didn't do it. I just took it. So, but we've already found the values for A1 and A2. Yeah, so one was 2/3. And the other one was what, 1? Let me make sure of that. Yeah, but that's what we already had in our solution, right? Yeah, where is it? Yep, 2/3. And -1. So if we just put that in here, what do we get? 1 minus 2/3 is 1/3. And then 1/3. One-third minus 1. So I don't know why this is giving me trouble, but it is. So 1 minus 2/3 was here, and this one was -1. So 1 minus 2/3, and then minus a -1 is +1. So that's giving me 2 minus 2/3. That's giving me what? 4/3. So I'm beginning to think this guy may be 4/3. Does that work? If that was 4/3, then when you put in 0, you'd have 2/3 minus 1 plus 4/3. And that doesn't work either. So something's wrong. Let's be a little more careful on A3. So A3 is just A1 minus A2. That's fine. And the entry in A1 was 2/3 that we checked. The entry in A2 was what? -1. That's fine. So it's 1 minus 2/3. And then it's -1, which is +1. Which is 2 minus 2/3, which is 4/3. Okay, so I'm getting this thing to be 4/3. But if I put 4/3 in there, I get 2/3 minus 1 plus 4/3. And I'm getting 1. I still think I should get 0. Well, I'm wasting a lot of time now, but it's not working out. I don't know why. Anyone see anything? It should be working.
Maybe the Q equation under A3, like the 1 plus 5 over 6.
The Q
minus
equals
one.
this one in here.
Yeah.
Could be, let's see. A3. So maybe I messed that up. Let's
So I-
see.
I redid it. And I think I got 1/3 this time.
Where? Where?
For
where did you-
A3, like when I plugged it into that Q equation.
Oh, in here?
Yeah, so I don't know if maybe,
You're getting a 1/3 for the corner entry?
yeah.
Okay, if it's
but I don't
1
know,
over,
Yeah, maybe try 1/3, but I don't know if I did it right either.
yeah, but if it's 1/3 here, that's for A3. So you're telling me this is 1/3. Yeah, if that is right. If that were 1/3, then you add it to the 2/3 and subtract the 1, and you get 0, which is what it should be. So how did you get 1/3 for this one?
I just redid it with that Q equation. I think when I did it earlier, I got the equation mixed up. Yeah.
Okay, so you just did this again?
Yeah, so I did the 1 minus A1 minus A2, but plugging in the Q's equation, and then I simplified it by hand. So I just kind of like redid it. I kind of redid what you did.
Okay, well, I'm glad you checked it because, yeah, I guess I was going with the -1/3. Did I check it? I don't even remember now if I checked that. Let's see. I thought I did. So why, okay, let's go through that again. A3 in the lower left-hand corner should be 1. Let's see, is that right? A3. Oh, no, there's the problem, I think. This isn't 1. This should be the identity, right? Because there's the problem. I don't think it's you guys. I think it's me there. I think I wrote something funny. Let's see. So up here, we have A1 plus A2 plus A3 is the identity, right? And we're trying to figure out A3. So this should have been A3 is the identity minus this, minus that. My bad. So that's the error. Now let's go through it. So we're trying to find the lower left corner of this. The lower left corner of the identity is 0, right? Because all the numbers are on the diagonal, so that would be 0. The lower left corner of A1, assuming that was done right, was -1. Yeah, it was negative, and then it was a 1 here. And then the A2, where was A2 done? A2 was -1, right? Let's see. Now let's see. A1. Okay. Trying to do this right.
I think the A1 was 2/3 and the A2 was -1. So you get -2/3 plus 1.
Which is not what I want. I
No?
still want 0. Yeah, I think because the identity in the lower left-hand corner has 0. And A1 in the lower left-hand corner, according to this, would have had 2/3, so that would have been -2/3. I think that's what that is, and what's in the lower
Yeah,
corner.
I think that's what it is. And then we get -1.
And A2 and the A2 looks like what? In the lower left-hand corner.
-1.
-1. So it's negative that, which is +1. And so we're coming up with 1/3, right? Which unfortunately is not what we want. We want 0. So why do I want 0? Because if you're going from 2 to 0 in no time at all, we agreed that that had 0 probability of happening. Now let's see. This is giving us 2/3, which is wrong. This is giving us 1/3, which doesn't agree with it even. Ah, goodness. So I don't know what's wrong, but I think it may be in this box here at the end. The identity certainly was wrong. Let's go through it one last time, though I hate to spend so much time on one problem, especially since I thought we were done with it. But that's how it goes sometimes. So A3 is 1 minus A2 minus A1 minus A2. Okay, so what was A1? A1 turned out to be this stuff. So if I do 1 minus this, it would be 5/6q plus 1/5 q squared. That may be a problem. I think I got tired here at the end. I'm looking at this minus, if I'm subtracting A1, it should be plus, change the sign, 5/6q plus 1/5 q squared. That should have been as q squared, it appears. That's the minus A1, then minus A2. A2 is this. Minus this, minus that. Okay, so I think it's my error. I think there should have been a squared there. But, okay, so that went on here. But is that really what's going on? I'm not even sure we looked at the squared. I think we just took A1 from before, right? So let's just go with this and see if it works. So what is all of this stuff? Doing a little more arithmetic here. So I'm just going to do an independent check here at this point. I hate to do this on the side, but I don't see any other place to do it. So I have, oh, well, there's, okay. So there's 2 errors. It's the identity, so that should be a 0 here. Well, no, it should be the identity in general. That part is fine when we're doing this part. But if we simplify what all of this is, that's the identity. And then we have 1/6 q squared minus 1/10 q squared. 1/6 q squared that's here, the 5s cancel. And then minus 1/10 q squared. Okay, and then the rest of it is 5/6q minus 3/10 q. 5/6q minus 3/10 q. Okay, so what does it all turn into? this equals what? I. 1/6 minus 1/10 is q squared. Oh, goodness. Common denominator is what? 30, I guess. So it's 30 on the bottom. 5 minus 3, which is 2. Q squared. Keep me honest with my arithmetic here. Common denominator is 30. So that would be 5/30 minus 3/10, or 3/30 rather. So that's minus 2/30 q squared. That seems to be right. And this is similar. This is 30ths, common denominator. So that would be 25 minus 9, which should be 16 q. Check my arithmetic. Five 30ths minus 3/30 is wrong. So that's 5/30 minus 3/30, which would be 2/30, but should be a plus.
I got the
Mhm.
same thing. I got the same thing, but as 1/15 and 8/15.
You're getting the same thing I'm getting here.
Yeah.
Okay, so 1/15 and 8/15. So let's just go with all of that. Okay, so that's what A3 is. So in the last entry, in the corner entry, the identity is 0. And in this one, it would be 1/15 times whatever q squared was in that guy. Q squared was what? Minus 19. And then plus, what did you say? 8/15. I guess I can go with that. 8/15 times whatever q is in the lower entry. And q in the lower entry was just 3. Okay, so whatever it is, it's not what we expect it to be. It's 24/15 minus 19/15, or 19/15. So that's 5/15. Or what? A third?
Yeah, that's what I got when I did it last time.
Is that the one we had last time?
Yeah.
And that's a third. Okay. So I guess what we're getting is 2/3 from this, -1 from this, and a third from this. That works. 2/3 and a third minus 1 is 0, and that should be right. Okay, so what's changed here? I guess the lower left-hand entry here is not 1, but a third. And I think maybe because I didn't have the square here that you gave me the right answer before, but when I put the square in here and I do it again, I'm getting a third now for what goes in here. So I think we got it finally. At least it corrects that answer, because when you put in 0, you get 0. And there was an error here. I had a q instead of q squared, and maybe that affected what we had here. But it looks like the third in there in the lower left-hand corner is correct. Sorry for all the time it took to find, but at least we got it. If, being practical, if this were a problem on the test and you went down this far and you got the wrong thing, but that was the only error, everything else was okay, you would just get a minor ding for getting the wrong answer. It wouldn't be a big deal. So it wouldn't be worth the time we spent, is what I'm trying to say, on the test, because there's too many other things to do. But it's nice to have the right answer, so I'm not gonna feel bad about that. Let's move on. What's next? Where did we start? We just did 1B. We didn't even do 1B, but I guess we did almost all of 1B. We did everything except for this one. Once you get that one, just subtract these two from 1 and you'll get this one. So we're almost done. Let's look at 2. 2. Two says, consider the Markov process having rates done in this diagram. So let's get a clean page here. So the diagram for 2 is this. You have 0, you have 1, and you have 2. And the arrows are just going this way, this way, this way, and this way. And they're different numbers or different rates, 1, 2, and 3. Write down the forward and backward equations. Okay, that's not bad. So that they look like this. That's the backwards. That's the forward. What is Q? From 0, you could only go up by 1. You don't go anywhere else. You don't go to 2. And therefore, this is -1 because the rows have to add up to 0. From 1, you just go to 2. So 1 to 0, 1 to 1, 1 to 2. This is this. This is be -2, and this is 0. -2. Wow. Doesn't want me to include minus signs. Okay. And from 2 to 0 is 3. You can't go to 1, and this would be -3. So this is how the Q matrix looks. Make sure I'm okay. 0 to 1 is good. 1 to 2 is good. And 2 to 0 is that. Yeah, that's fine. So you could either write down this and say where Q equals this, or you could actually write this in here. The only thing that I haven't shown you yet is what P of T is, and that's this. Well, let's see, it should have been 1. Yeah, you better keep an eye on me. So 1 to 0. 1 to 1. 1 to 2. 2 to 0. That's a 2. 2 to 1. 2 to 2. Okay, so now everything is described, the matrix P of T and the Q matrix. So we're done with A. Solve for the steady state distribution. Okay, so this is, so far this is A. B, steady state distribution. Well, first you'd have to find the stationary distribution. So that would be this equals pi q. Okay, well, two choices, hand or using the algorithm. It's only 3 by 3. I think the hand will probably be quicker or competitive at least. So what would it look like? It would look like pi 0, pi 1, pi 2. That vector times the Q matrix, which is up here, -1, 1, 0, 0, -2, 2, 3, 0, -3, and set that equal to the 0 vector. Okay, so when you multiply through, when you multiply this times this, you'll get the equation minus pi 0 plus 3 pi 2. This times this goes away because it's multiplying by 0, and that all equals 0. When you do the other two equations, it's this row times the second column. So that'll give you pi 0 minus 2 pi 1 equals 0. And then the last equation would give you 2 pi 1 minus 3 pi 2 equals 0. What did I do to get it? I multiplied this row times the third column. Okay, so I think looking at the first two is almost enough to solve this, because we would have that pi 0 is 3 pi 2. So we might say that, no, what did I just say? Pi 0 is 3 pi 2. Or pi 2, if you like, is pi 0 over 3. Looking at the second equation, you would get pi 0 is equal to what? 2 pi 1. Just bringing that to the other side, which is the same as saying what? Pi 1 equals pi 0 over 2. You don't need the third equation, because the fourth equation, which is not said yet, but it's there, is that pi 0 plus pi 1 plus pi 2 is equal to 1. So whatever pi 0 is, just leave it like that. And remember, pi 1 is what? Pi 0 over 2. And pi 2 is pi 0 over 3. So this should be easy enough to solve, because you can just factor out the pi 0. And it's 1 1/2 and 1/3 equals 1. So this is 1 and what 5/6, 3 6 and 2. So yeah, it's 1 and 5/6. So this is 1 and 5/6. So this is equal to pi 0 times 1 and 5/6, and 1 and 5/6 is the same as 11/6. So pi 0 times 11/6 is equal to 1, which means what? Pi 0 would be 6/11. Pi 1 would be 6/11 divided by 3. So that would be 2/11. And pi 3, pi 2 rather. Where do we have what that is? Pi 2 is, yeah, I think I messed it up. Let's see. Pi 1 was pi 0/2. So that should have been 3/11. Pi 2, yeah, over. This one is 3/11. And this one is this divided by 3, which would have been 2/11. So that should be equal to the stationary distribution. It all adds up to 1, which is 11/11. And if you wanted to check your work, which is always a good idea, you can put it in here and see if it works. Actually, it helped us last time to catch an error, so why not do it again? 6/11 goes here. Pi 1 was what? 3/11. And 2/11. So if you multiply the first row times the first column, you'll get 6/11 with a minus, and then minus 6/11. So that'll give you the 0. If you multiply this row times the second column, you'll get 6/11 minus twice this, which is minus 6/11, and that's giving you this. And if you multiply this row times the third column, you'll get 2 times this, which is 6/11 minus 3 times this, which is again 6/11, and that's working. So this is the stationary distribution. They asked for the steady state. The steady state will be the same as the stationary if it's irreducible. It's irreducible if all states lead to each other. Also has to be what? Positive recurrent, but that is automatic because there's only 3 states. And we know that it's positive recurrent. And we don't have to worry about aperiodicity. That only matters when we're talking about chains. It doesn't come into play for processes. So since it's irreducible and positive recurrent, this is also the steady state. Okay, so we're 2/3 done with B. We've got the stationary distribution, and it's also the same as the steady state distribution. So that's B. What is C? C asks us to solve for expected time it takes to go from 0 back to 0 here. Expected time it takes to go from 1 back to itself, and the time it takes on average that it takes to go from 2 back to itself. These are usually called M0, M1, M2. In a Markov process, the relationship is the following. So for an irreducible positive recurrent chain, the stationary distribution looks like this. So if you want, in this case, we already figured out where all the pi's are. So when x is 0, for example, we have that pi 0 is 1 over minus the rate going from 0 to 0, M0. The rate going from 0 back to 0, we'd have to look at the Q matrix, is -1. So we negate that, making it 1. So in this case, this just becomes 1 over M0. But this we already know from part B was 6/11. So solving for M0, M0 turns out to be 11/6. Similar calculations work when x is 1 and 0, or x is 1 and 2. When x is 1, Then what does this equation say? It says pi1 is 1 over minus q11 m1. Q11 can be found from the Q matrix to be -2. And we're negating that, so it becomes 2. So this becomes 1 over 2 m2 in this case, but pi1 from above was 3/11. So you can now solve for m2. So 11 over 3 would be equal to 2m2, which implies that m2 is what? 11 over 6. Oh, let's see, is that right? I got the same answer for each one. I'm a little suspicious. Let me make sure I did that right. Yeah, I guess so. Same answer. And what about the third one? If or when x is equal to 2, pi2 would be 1 over minus q22 m2. That's the result of the theorem. Q22 is what? -3. So when you negate that, it just becomes 3 on the bottom. So this becomes 1 over 3 m2. But pi2 from part B was 2/11. So 2/11 equals 1 over 3 m2. If you just flip things over, 11 over 2 would be 3 m2, which once again is giving you that m2 is 11 over 6. So they all have the same average time to return, and in a way that makes sense. 11 over 6 is almost 2, because if you go back to the diagram, if you're going to go from here back to itself, there's only one way really to go back to itself from in this diagram, and that's just to go around the circle. And now you can see that if you started here, the time it would take to go around the circle should be the average time it takes to go around the circle, no matter where you start. Because no matter where you start, you're still transversing 3 arrows whose rates are 1, 2, and 3 in different orders, but they still have the same rates. So that sort of makes sense why in this case, all the m's are the same. Be careful, they won't be the same in general for different diagrams. But in this case, since going back to any one state to itself involves moving around these 3 arrows and they all have the same rates, the average time is almost 2, 11/6. Okay, that's number 2. Questions on number 2? One thing is obvious. It's much quicker than number 1. On the other hand, there's 2 reasons for that. First of all, it didn't ask us to solve the system of equations, which involves eigenvalues and all of that stuff. So if you're asked for solving for the P of T matrix, get comfortable, that's going to take a little time to do. And then if you make a mistake, as we did at the end, and you happen to catch the mistake and want to find out what's wrong, that's going to double the time probably. Unless you're lucky and spot it quickly. In this case, we did the same kind of stuff. We found the solution, we checked it, but it just wasn't as involved. Questions on number 2? Okay, I'm going to have a little sip of water before I do 3, or whatever's next. So what is next? Number 4. Okay, let's flip the page. Add a page, throw some lines on it, and off we go. So number 4 looks a little bit like number 1. I'm trying to see, or like number 1B. It has 3 states. It says for a Markov process having this state diagram, determine the steady state. And okay, so this is a 2-4. Okay, so number 3, or I'm sorry, 4. They give you this diagram. It's a birth death chain, so it's just going up or down by 1 each place. The rates vary. 3, 2 here, and what, 4, 3 here. Determine the steady state distribution and the P of T matrix. Okay, well, let's do it in the order required, I guess. So for the steady state, we need to first find the stationary. So we need to do pi q equals 0. Be careful you don't mix this up with what we did on the previous exams. So before we were doing something that looked like this. That's good for Markov chains. You're not going to see very many Markov chains, I don't think, at all on this test, because we're in chapter 3, we're doing Markov processes. So that means this will not apply. This does not apply for what processes? For Markov. What does apply is this, which we just did in problem 2. Okay, so we just need to come up with the Q matrix and go through something like we did before. Q matrix, we should be able to come up from the diagram. From 0, you can go to 1 with rate 3. You can't get to 2 with 1 step. And then this would be -3 because the rows have to add up to 0. From 1, you can go to 0 with rate 4. Or you can go to 2 with rate 2, and that makes this rate -6 because again, the rows have to add up to 0. For 2, you can't get to 0 in 1 step, but you can get to 1 with rate 3, and that would make this -3. So that's the Q matrix. It's important to be able to get the Q matrix because without it, you can't even start the problem. So hopefully that makes sense. And then we just do what we did before. Pi 0, pi 1, pi 2. There's only 3 states here. You multiply that by the Q matrix. -3, 3, 0. 4, it should be -2. Well, it should be -4, actually, -6, actually. Not sure what I had in there before, but it should have been 6. It again has to be such that the row adds up to 0, right? And this does already. Okay, and to find the stationary distribution, set this equal to 0, 0, 0. And it's, again, I think you don't need the algorithm for this. There's an algorithm which we did in class that you could be questioned on, but I don't think for these examples that really is necessary because I think doing it by hand is not that hard or long. So the first equation would be achieved by multiplying this times the first column. So it'd be -3 pi 0 plus 4 pi 1 times this 0, that would be equal to pi 0. Whoops, would be equal to 0, actually. And let me scroll down. I lost a few things here. I lost an equal sign here. Minus, should have been minus 3 pi 0 plus 4 pi 1 equals 0. That part is better. The second equation would be what? First row, or the row here times the second column. So it'd be 3 pi 0 minus 6 pi 1 plus 3 pi 2 would be equal to 0. And then finally, this row times the last column. The 0 times pi 0 will go away. So you have 2 pi 1. And you'll have minus 3 pi 2. And that will be equal to 0. Wow, everything I'm writing is disappearing behind me. So what do I have? 2 pi 1, I think. Okay, and then there's the hidden or easily forgotten equation that you don't want to forget, which is pi 0 plus pi 1 plus pi 2 equal 1. Because that's saying it's a distribution that the probabilities add up to 1. Okay, well, the first equation, if we just move this first term to the other side, would give us 3 pi 0 equals 4 pi 1. So I'm looking at that. I'm looking at these two equations. They're the easier of the two. And I think I can make a go of just those two. So this one, if I bring this to the other side, I get this. And then I can solve for pi 0. I can solve for pi 1 in terms of pi 0. Let's see if that's what I want to do. No, I want to solve for everything in terms of pi 1. So pi 0 would be what? 4/3 pi 1. That's one equation of importance. Then I'll go to this one. 2 pi 1 minus 3 pi 2 equals 0. So I'd like to solve for pi 2. So 3 pi 2 would be equal to 2 pi 1, which means if I divide by 3, that pi 2 would be 2/3 pi 1. So far I have pi 0 in terms of pi 1. Make sure I did this right. Pi 0 in terms of pi 1, yes, 4/3 pi 1. And I have pi 2 in terms of pi 1. It's 2/3 pi 1. Okay, so I know what everything is in terms of pi 1. Slip it back into this distribution equation. So I know pi 0 plus pi 1, but pi 1, oh goodness, no, don't do it that way. So pi 0 is 4/3 pi 1. Put that in for here. 4/3 pi 1 plus pi 1 plus pi 2, but pi 2 is 2/3 pi 1. And those three terms add up to 1. So I recognize that I could get all the pi's in terms of pi 1. And if I do that, and that's what I've done in these two equations, then I can get one equation and one unknown and solve for pi 1. So I can factor out the pi 1 now. And this is 4/3 plus 1 plus 2/3 equals 1. But 4/3 and 2/3 is 2, and another one makes 3. So 3 pi 1 is 1, which means pi 1 is a third. But once I know pi 1, I know pi 0, because pi 0 is what from this equation? 4/3 times pi 1, and pi 1 was a third. So this becomes 4/9. And in a similar manner, pi 2 is 2/3 pi 1, but pi 1 was a third. Is that right? Yes. So this is 2/9. To make sure, we should add them all up to make sure they add up to 1. 4/3, which is this one, plus 1/3. I'm sorry, 4/9, which is this one, plus 1/3, plus 2/9, which is pi 2. Well, the 2/9 and the 4/9 add up to 6/9, which is 2/3, and then the 1/3 more make 1, so it all checks. So we're done. The stationary distribution is what? Pi 1 was a third, I believe. No, already pi 0. Pi 0 was 4/9, a third, and this one was 2/9. Okay, so that's the stationary distribution. Any questions on that? Pretty much similar to the previous problem. Not the only way you could do you could solve the equations in many ways. This is just one way, but it's not too bad. Could you check it? Sure. Should you? Why not? It's quick. So you put in 4/9, a third, 2/9. Put it in right up here, 4/9, a third, 2/9. If you multiply this row by this column, you get -3 times this, you'll get -12/9. And then a third times 4 is 4/9. Well, actually it's 4/3. And the third product gives you nothing. This one was a 6, by the way. Okay. So if you add this up to this, you get 0. Well, yeah, this is divide by top and bottom by 3. This is -4/3. This is +4/3. So you do get 0. So that's a part of the check. What about the next one? It would be 4/9 times 3. 4/9 times 3 plus 1/3 times -6. So that would be -6/3. And then 2/9 times 3, which would be what? 6/9. Okay, so what is everything going on here? I don't know. It looks like, this looks like 4/3. 4/3 minus 6/3 is -2/3, and this is a positive 2/3, so that does equal 0, so that works. Finally, the last equation is this times this, and that's just 2 times a third minus 3 times 2/9. That's -2/3 and +2/3, so that works as well. So why not check? It's so easy to check, and if it were wrong, you can save, a lot of points easily. Just go back and find the error. Okay, so we found the we found the stationary is at steady state. Need to say a word why. It is. It's irreducible. You can get from one state to the other. They're only positive recurrent states, so it's automatically the steady state. But you need to say those words. You need to say that it's irreducible and positive recurrent. Periodicity doesn't matter for continuous time processes. Okay. So I'd say the easy part of the problem is done. The harder part of the problem is to find P of t. Why is it harder? Well, it's harder than the other one we did. So what do we ask? Any questions before I move on to the second part? Okay. So the remaining part is to find all of these guys. That's the time dependent part of the problem. So it would be 0, 0 of t, 0, 1 of t, 0, 2 of t, 1 of 0 of t, 1 to 1 time t, 1 to 2 and time t, 2 to 1 and time t, 2 to 2 and 2 to 0 and time t, sorry, 2 to 1 and time t, and 2 to 2. So that's what's been asked for, 9 different transition probability functions, okay? What makes this a little more impressive, I guess, is that we can't just eyeball what some of them are like we did before. So like in 1B, there were some ways where you couldn't get it from any state to any other state. So those probabilities were 0, but that's not the case here. You can start anywhere and get anywhere else in any time you want. So there's no easy ones. These are all, you need to find all 9. Well, there is this. If you can find 2 out of 3 for any row, then the last one is just 1 minus the 2 other elements. Why? Because this is a stochastic matrix again. So it's not all 9, I suppose. You can think of it as 6 out of 9, as long as you got 2 for each row. Okay, well, need the Q matrix, but we got the Q matrix. It's up here. Good. Need its eigenvalues. Why? Because the way that I'm approaching this now is more linear algebra problem. So we want to do this once again. We want to say that it's A1 e to the omega 1 t plus A2 e to the omega 2 t plus A3 e to the omega 3 t. The omegas are distinct eigenvalues. If we don't have distinct eigenvalues, then we're in a bit of a bind, but it's unlikely because that's all we've been talking about, distinct eigenvalues. Omega 1, omega 2, and omega 3. I know that one of the eigenvalues is 0. 0 is always an eigenvalue of the Q matrix. And the reason for that is if you take any Q matrix and you multiply it by a vector, like in this case 1, 1, 1, you will always get 0, 0, 0. That means this is an eigenvector corresponding to eigenvalue 0. Minus, we'll call this one this guy, because then this just becomes this, which is easier. Okay, but the other 2 are not so obvious. So probably you should be able to do that by your calculator. So why don't you find the eigenvalues of Q for us? And I'll call them omega 1 and 2. And as I said, omega 3, we already know that one's going to be 0. Or one of them is going to be 0. We'll call it omega 3. So I'm waiting for somebody to give me the other 2 eigenvalues from their calculator. Let me know when you got it.
-3 and -9.
Okay, sounds good. They're nice numbers, -3 and -9. It doesn't matter what order you put them in. Just be consistent in this. So since this is, I listed this as omega 1. So I'm now going to call this -3 t. And this one over here will be minus 9t. Is there any problem getting those eigenvalues for anybody? Hopefully it's getting easier and easier because we're just using the calculator to do it. Okay. So what's left? What's left is to find the A's. I'm going to go through that quickly because we've done a similar kind as before. It's very similar to problem 1b. So if t is 0, you get p of 0 here, and that would correspond to the identity matrix. And when you put in zeros for the t, you'll just get a1 plus a2 plus a3, and adds up to the identity matrix. So that's where to start. Where do you go to next? If you let t be 0 after you differentiate. So differentiate this one, and we've done that kind of thing now a few times. This is constant. These are constant 3x3 matrices, so they don't change with time. But when you differentiate the exponential, you'll get itself times the rate there. And this one goes away because it has no time dependency at all. Okay, and if you let t be 0 in this, you'll get p prime at 0, or t evaluated at 0. Think of it that way. First differentiate, and then evaluate when t is 0. That gives you q, which you already know. But on the right side, when you put in zeros, you'll get minus 3a1 minus 9a2. That's our second equation. Every equation here that you could find and you could box is worth money in the bank, or points on your test to be more explicit. So you should do these equations. And the last one happens when you differentiate this thing twice, and we've seen that now. If you differentiate it twice and evaluate it when t equals 0, what do you get? You get q squared, right? And when you differentiate this thing again, another factor of minus 3 will come out here, another factor of minus 9 will come out here. And when you evaluate at 0, what do you get? You get a1 times 9, which is minus 3 squared. And then you'll get what? 81 times a2. And that's your third equation for the A's. If it were 4x4, you would need to differentiate one more time, and it would work out to be equal to q cubed. Okay, just to let you know in case it goes past 3x3. From here, I'm almost ready to stop. Why? Because we've done similar things like this already. So for instance, we can solve for a2 in terms of a1 here, substitute that in here, and solve for a1. Let's do a little bit of that. So looking at this equation, we can just say that 81a2 is equal to q squared minus 9a1. And if you solve for a2, you would just divide by 81. a2 would be 1 over 81 times q squared minus 9a1. Okay, that's solving for a2 in terms of a1. I mean, you could have as well solved for a1 in terms of a2. So it's arbitrary which one you do. You have a choice. Let's just make sure I did it right. 81, 82, I'm solving for 82. So 9 q squared minus a1, that looks fine. Divide both sides by 81, that's fine. If you then take this equation and put it into this one, you have q is equal to minus 3a1, which you don't know yet, minus 9a2, but you have a formula for a2, it's this guy. 1 over 81 q squared minus 9a1. And this one is important because q is known, and so is q squared, because you can find q squared by the calculator just by squaring it by hand. So from this equation, you can now solve for what? A1 in terms of known stuff. Let's do it a little bit again. Q is equal to minus 3a1. Minus 9 times 1 over 81 is minus 1 over 9. What's inside? 1 over 81 times q squared. And this is minus 1 over 9 a1. Okay. So writing things out, q would be minus 3a1. This times this is what? 1 over, we could call it 9 cubed if you want. Q squared. And then this times this would be 1 over 9 squared, 81. Keeping the terms that have a 1 together, it looks like we have a 1 over 9 squared a1 minus 3a1. And those are equal to q plus 1 over 9 cubed q squared. And meanwhile, this on the, because you can factor out a1. And so you have 1/9 squared minus 3. And whatever this is, you can then solve for a1. So a1 would be q plus 1 over 9 cubed q squared. All of that divided by this number here. 1 over 9 squared minus 3. Which tells you that you have a1 in terms of q and q squared. Q is known and q squared is not hard to find. Okay, so now you have a1 in terms of known quantities, but you can go back and substitute this. So sub this into this, and that'll give you a formula for a2. See if I can squeeze it in here, take the pictures away. So a2 would be 1 over 81 q squared minus 9a1. But a1 is all of this stuff. So I'll just write it. Q plus 1 over 9 cubed q squared all over, what is it? 1 over 9 squared minus 3. Let's see if I'm doing this right or if I messed it up. A2 is 1 over 81 times the quantity q squared, which is fine. And then for a 9a1, I put in all of this. So I'm a little sloppy here. It should be like this. And this should be over here, right? And let's double check. 1 over AB1 Q squared minus 9. And for A1, I put in all this stuff. Yes. Okay, so this is a formula for A2. In terms of known stuff, in terms of Q and Q squared, that's the important part. And then finally, A3 can be found from this formula up here. And so it's the identity, not 1. I think that was part of my problem last time. It's the identity minus A1, A2. And now substitute this in for A1. Substitute this stuff here in for A2. And you'll have a formula for A3 that's all in terms of Q and Q squared. I'm not going to write it because I don't think it's needed. I think you can figure it out yourself. Okay, so now we have all the A's in terms of these things, in terms of Q and Q squares. So you should numerically determine what the A's are. Q is not a numerical. Q is what? It's there. If I go up high enough, there it is. That's Q. And it's not hard to get Q squared. You can use the calculator just to square this matrix. So you know Q and you know Q squared, which means you know A1, A2, and A3 in terms of known numerical expressions. So you have numerical expressions for those. So the answer should be, P of T should just be A1 e to the, help, is it minus 3t? I forgot. Yes, minus 3t. Plus A2 e to the minus 9t plus A3. So once you have your numerical expressions for this, this, and this is your answer. Is this getting more familiar? Because we've done it a few times now.
Yeah, I had a question. Where did you get 1 over 9 from?
Where did I get what?
On top,
How far top do I have? to
right
go?
there, where Q equals negative 3A1 minus 1 over 9.
Oh, this
Right there.
part here?
Yeah, minus 1 over 9. Where did that come from?
I think, well, let me see. Let me get the picture out of my way. Well, I had all these equations. I had this one, and this one, right? So what I did in this one, I'm trying to get my order here first. Hang on. So what I did is I took the last equation here, this one, and I solved for A2. So I brought the minus 9A1 to the left side and divided by 80, and then divided by 81, and that gave me A2. So I have A2 in terms of A1. And then in this equation, let's see, yeah, and then in this equation, the one right above here, all I did is substitute for what A2 was in terms of A1. So I put this expression in for A2. Oh, and so is this wrong? Maybe it is. Let me see. Yeah, so you're questioning me the 1/9, right?
Yeah,
Are you thinking it should be just -9?
I thought so too, but I don't know. That's why I asked.
Okay, all right, let me check. You may be right. This part, let me just review it all. Yeah, because it's easy to mess up. This part looks fine. And that means solving for A2. Looks like Q squared minus 9A1. That looks fine. Dividing by this looks fine. Okay. Oh, no. All right. I think it's, well, let's go with it a little further. So you're okay with this for being A2, right? Let me just put a circle around that too. This one's okay for you?
Yeah,
Okay. So then that one I'm putting into here. So where you have A2 equals that, I'm replacing this A2 but that. So when I do that, the -3A1 will still stay the same because I'm not touching the first term. But -9 times this, when I have the -9 over an 81, 9 went into 81 9 times, and that's how you got the -1/9. And then the rest. Well, let's see. All right, I thought that's what I'm doing. Let me make sure that's what I'm doing. I think I did it up here. So let's track it. The -3A1 was good. The -9 is good. I put this in for that I did up here. And I canceled this 9 with the 81. That's what I meant to do. This part here shouldn't be here. Do you see what I did or didn't do? So you caught an error. That's good. I'm putting this expression here in for the A2 here, which gives me this. And then I did -9 divided by 81. I canceled that, but this shouldn't be here. So I'm going to erase that. Thank you for the error or catching the error. And I can see what I did. I did the cancellation mentally, but then I didn't cancel it down here. Are you good with this now? Or are you still not sure?
yeah, I'm okay with it now.
Yeah. I did the cancellation mentally, so it should be -1/9. But then I forgot to cancel it inside, which I should have because I did it in my head. So then this should be okay. Now let's see whether that error can still comes up. Probably will, right? Assuming I didn't make another error. So when I did this, I'm multiplying through. So this should be now this should be that, right? -1/9 times this. And then this times this remarkably turns out to be right. Okay, let me see if I did this right. -1/9 times that, that's cool. And then this times this is 1/9 squared. Yeah, I think the rest is okay for this. But now you got me looking past here. Oh, so what's the good news on this? The good news on this is this equation just has A1. So we should be able to solve for A1. So let's make sure that everything works after that. So yeah, I don't think it does. So I think we have to rework this. Let me see what I think I should do. Now that I'm confident of this, what I should do is bring the 1/9 Q squared to the other side. And there's that uncanceled 81. So I'll just make it 1/9 now. So when I bring this term to the other side, I do have that. And then what should be left? What should be left are just these two terms. So this one should be -3A1. Well, no, let's see. Oh, I'm sorry, it was okay. Why? Well, let's see. Yeah, this was okay, so it should be this. If I bring this to the other side, which I have now, so it's 1/9 q squared. Then what's left over here is 1/9 squared a1, that's this guy, and the minus 3a1, that's this guy. And then do what? Just factor out the a1. And so this is fine, and this is fine. And then solve for a1, so it would be this over, this would be what, 1/9? Because that's what's over here. So the error that has to be tracked down all over 1/9 squared. This looks okay now. Okay, but that's a1. And I wanted a formula for a2 as well. So what did I do for a2? I went back here. I had this formula for a2. Let's make sure it's okay. I think I'm fine for a1. I'm worried about a2. So do we have an equation for a2 anywhere here? We probably do. Right here. Okay, so from this, I think I solved for a2. So how would that go? Bring the I'm a little mixed up because I have the arrow going this way and I'm not sure why. So at this point, I've corrected a1. I think a1 is okay. And I think I did a2 here by putting it back into this. So let's actually make sure this is fine. Let's check. Well, I'm not sure I see everything I want. But at this point, I have a formula for a1 that I think is fine. And I think I could go back into, since I got that formula for a1 by using this one, I think I want to go back into this equation and just solve it for a2. That would be another way to go. So from here, if we wish, we can say that I can bring the minus 3a1 to the other side. So I have q plus 3a1 is equal to minus 9a2. So if I want to use this equation here, that's what I'm doing. I can just now divide both sides by minus 9. So it would be minus q over 9 minus 1 over 3 a1 would be equal to a2. So I'm coming from here. I'm not sure I did that before, but this should work because this is an equation involving a1 and a2, and I already know a1. So if I bring this to the other side, I get that, and the minus 9a2 is still there. Divide both sides by minus 9, you get this. Minus 9 here gets you this, and that's this. So now you have a2, but if you want now, you could put in what you just found for a1 into here. So we already found a1, and if we wish, we could put that into here. And if you do that, you'll get a formula that looks like minus q over 9 minus 1/3 a1. But a1, you'd have to put in all of this stuff. Q plus 1/9 q squared all over 1 over 9 squared minus 3. And now that's all a2. But that's progress. Why? Because that's a2, all in terms of q and q squared. And then the rest of it is using the remaining equation, which is this one. And you already have an equation for a1 and a2, so just subtract them all from 1, which is really going on down here. And yeah, I didn't actually do it, I guess, but I was substituting this one in. But you could put in both of your equations, this one for a1 and the other one for a2. I'm not sure this one is still, this one may have an error, but I would probably put in this one for a2. There's a variety of ways to go here. Not there, up here. So put this in for a2, for example. Instead of this one may be suspect. I'm not sure the cancellation is. So what am I confident of? I'm confident of this one and I'm confident of this one. And if I know both of those and I subtract it from the identity, I'll get a3. So that'll be my last. So I have everything in terms of Q's. Thanks for catching the error though. Because I wouldn't have, because I'm going to go on. Why? Because if once the A's are right in terms of known quantities, then we're done. And if you get done and you're not sure it's right, then do what I did in the last problem. Put in t equals 0. Because when t equals 0, these things should simplify to be, when t is 0 over here, this should be the identity. And if this doesn't turn out to be the identity, then you made an error someplace. Probably an arithmetic error like I made over here. Questions on this one? Well, we're going longer than I planned because we still got stuck on 1. Let me see what's left. Not sure what's left. We just sort of did 4. Is there something else? 4. Well, there's 5. Why don't we do 5 and call it a night? I think 5 is quick. We'll see. Flip the page. Add a new page. Get some lines and go for it. So, okay, 5 gives you this one. Okay, And it says calculate 5A at least. Says calculate P02. Which is a little more reasonable. You only ask for one instead of everything. Now we got different ways to do this. We've got the way that we've been doing it. Now, I don't think the way we've been doing it's going to work. Let's check why. So what would the Q matrix be for this? There's only 3 states. From 0, you can go to 1. You can't get to 2. So this is the first row. From 1, you can't go down. You can only go up. So this would be -1. And from 2, you can't go anywhere. Oh boy. Let me see if I can regain what I lost here. Okay, I got it, but let me see if I can share it with you. Maybe. Yep, okay. But I think that's going to happen again unless I do something different. Oh, okay, I guess I didn't recover all my Q matrix. So what does it look like now? Oh, 0, you can't go anywhere, right? That's what I had before. Okay. You want to find the eigenvalues? Go for it. What do you get?
Professor, I didn't use a calculator, but you're just gonna get repeating ones, right?
I think so. Yeah, I think so. Well, 0 might work still, right? Let's see if you
Oh,
put in
0
one.
and then repeating ones. Yeah.
I think if you do this, you still get 0, 0, 0.
Hmm.
So yeah, there's, oh goodness. OneNote is getting tired, I think. Probably we all are. Okay, so let me try to put this in here. But I think you get 0 and two ones. Does that sound right?
Yeah, I think so. I didn't calculate it, but I think there was, I remember seeing something, if you have like a matrix with just like the diagonal, super diagonal, it's just
Well, yeah, but I'm not 100% sure, and I've already made a little errors along the way. So let's let somebody do it on the calculator. Just give me the eigenvalues for this. What does the calculator say?
Give me a second while I do it.
Say it again. Yeah, I'll give you a second. Sure. I mean, I can see that 0 will be an eigenvalue, and I think 1 will be as well. Okay, while you're doing it on the calculator, I'll play with this in a different way. So a different way of doing it is take the matrix, subtract X off along the diagonals.
I got it.
What'd you get?
I got 0 and then -1 with multiplicity of 2.
Oh, -1. Interesting. Okay. All right. So you're getting this and this. Is that what you're saying?
Yeah.
Okay. Well, all right. So my guess was off. But the point is what? You got this. You don't have distinct eigenvalues. Which means what? The method that I've been doing today and this week in class doesn't work. Because for that method, What method are we talking about? The method where I do this, where I say P of t is equal to A1 e to the omega 1t plus A2 e to the omega 2t plus E3 e to the omega 3t. And then I usually, before I even write this, I usually say, provided that the eigenvalues are all distinct, which means they're not, no two are the same. But here two are the same. So what does that mean? Don't use this. Okay. You can't use that unless the eigenvalues are all distinct. Okay, so since I haven't given you another way to do it using eigenvalues when two of them are the same, are you in trouble? Well, no, yes and no. I mean, one method is gone, but there are other methods. So what's the other method? The other method would be to do the equations, differential equations. And I think we've avoided that about as far as I can tonight. So let's do a differential equation before we stop. So we still need the Q matrix. The Q matrix is what I said it was. It was what? 1, 0, and a negative 1 here. And it was what? 1, negative 1, and a 0 here, and all zeros here, right? And these are the eigenvalues. So what we can go back to, and should go back to, is the forward and backward equations. So let's do that. So what that still holds in general, P prime is equal to Q P of t, which equals P of t Q. We've been using the forward equations most of the time, and it seems to pan out, so let's stick with that. All right, so in our case, it would be P of t times Q, which is this guy. Negative 1, 0, 0, negative 1, 1, and 0, 0, 0. Okay. And, well, what is P of t? P of t is a 3 by 3 guy. Don't start leaving me now. Okay. P0, it's going to go on make it. All right, I'm not going to press my luck. I'm going to write all of these without the dependency on time, just so it doesn't get, I'm trying to keep it happy. Even though I didn't put the t's in here, they're there. And what's over here? Over here are the same quantities, but with primes everywhere. But the only one we really want is P02. So where's P02? P02 is over here. I'll put the prime in there. Okay, so can we form an equation for P02? Yeah, because what the equation that comes to mind is this one, P02 prime, and I'll put the t's in here. And how would you get this entry? You would get that entry by multiplying the first row times the last column. This one times that one will give you this entry in the matrix. So it's going to be what? It's going to be minus P00. Just doesn't want to keep that one there. Plus P1 of 0. And well, but it would be this times this, so that's gone. So you're, okay. You're multiplying this row by this column. So it's this times this, which is 0. It's this times that, which is P01 of t. So this one is gone. This one survives, and then this one times that is 0, so you get this. So if you just went straight for the one you're after, it would be P02 prime of t is P01 of t. And again, even though it keeps leaving me here, P02 prime is this one. And you would get that by multiplying the first row here by the last column here. And that's how you get this equation. Okay, well, that would be not too hard to do if you knew what P0T of is, right? If you knew what P0T of is, then you would just integrate it to get P0. If you knew P01 of t rather, then you could just integrate it to get this, and that's what you're asked for. So keep your mind on what they're asking for. They want this. Okay, so, but to find this involves having this, so we probably should write down the equation for this. So where is that? That's over here. P01 prime is sitting there. So what is the equation for that? P01 prime would be achieved by multiplying the first row here by the second column here instead of the third. So when I do that, you're going to get P00 times this. And then you're going to get this with a minus in front of it. And that's it. Okay. So might as well write in the first entry here because that's where we're headed. But yeah, that's why I didn't put in the prime. Doesn't like it. P00 prime, P01 prime. Okay. So when I solve for P01 of prime, I get this one because I multiplied this row by that column, and that's this. Okay. But it's not clear how to solve this. And I certainly, using this equation, I would need P00. So we might as well go back to the first one. Is there an equation for P00? And the answer is yes. P00 of prime would just be equal to this row times the first column, which is minus P00 of t. Okay, so what I think you need to do is you need to solve these from the bottom up. This is the easiest one because the variables will be separable. If you can find P00, then you'll know that this. Then I think you'll need the linear equation to solve this. And once you solve for this, then all you have to do to get this will be to integrate. But it's not an easy problem because it involves solving 3 differential equations, okay? And why is it 3? Well, I've tried not to make it 3. All I really want here is P02. That's all that's asked for. But if I put down the differential equations for P02 prime, it turned out to be this one. And if I don't know this, then there's no way to get this because I have 2 things that I don't know. So one way to go is just to follow the program. Do this first. Do this next. And finish with this. Now, if you're going to ask me, is there another way to do it? Maybe. Maybe. What might be another way to do it? The backwards equation. Right? I don't know if it's quicker. And at this point, I'm ready just to do this to show you how this works. But I will cover all my bets by saying the backward equation can be used as well as the forward equation, and it might actually give you something faster. If you're curious about that, try, write it out yourself and see what it looks like. I'm almost tempted to do that, but I think I better just stick with the one I have here. So sticking with this one, this is the easiest of the three. Well, I hope. If we let y of t be equal to p00 of t, then this equation says dy dt is equal to minus y. Because it's got the derivative of the same, it's got the derivative of the equation that you're, of the function that you're trying to find. So it's dy dt equals y with a minus in front. So let's actually solve that differential equation. Get all the y's on one side, all the t's on the other. If you can do that, the variables are separated, so you can integrate both sides. Roughly what you're doing here is you're getting the log of y. Here you're just getting what? Minus t plus a constant. And when you try to solve for y, you exponentiate both sides. E and log are inverse functions, so this just becomes y. It's really y of t, but the t is suppressed. And over here, using rules of exponents, it's e to the minus t times e to the c. And e to the c is just a constant. So you could write this as a constant times e to the minus t. Okay. But that's equal to y of t. And if you put in t equals 0, you'll get y of 0 equals k. So that tells you what k is. K is really the initial value of this thing. But what is the initial value? What is y? I'll go back up here. Y was this. So when you put in 0, it's the probability of going from 0 to 0 in no time at all, which we agreed to call 1. So we have found y of t, because this is just 1. So y of t, which is the same as p00 of t, is just 1 times e to the minus t. So it's just this. Okay, so that's the separation of variables concept. So the solution of this is just e to the minus t. Easy enough to check if you wanted to. If you differentiate this, you'll get e to the minus t with a minus on coming out from the chain rule. And if you just put this in here, you'll get minus e to the minus t, and you get the right answer. Okay, so we know what p00 of t is. So this one is done. And we can move to the next one. The next one is this equation. Let's write it out. It's p01 prime of t is equal to p00 of t. That one we just figured out is e to the minus t minus p01 of t. Okay, so that's what's next on our plate. I need to scroll down and get a little more room. So any questions about, there's a 3-step process here. I've done the first step so far by separation of variables, able to figure out that p00 of t was just this. If you stick that into here, this becomes the next equation to solve. Okay. So let me move to that one. I'm trying to think whether I want to stay on this sheet or move to another one. I think I'll move just because I'm afraid I'm going to start losing stuff. So write down where we are. We need to solve this. If we can find what P01 is, then we'll put it in here. And then to get this, all we have to do is integrate P01. So this is sort of the critical step. The first one is separation of variables, not too bad. This one will be a little harder, but if we can get this far, then we'll get this just by integrating this if we can. Let me see if I can write some of this down. Well, maybe I'll have you help me. So somebody just remember what's in this equation, and someone else remember what's in this equation. I'll see if I can duplicate it by just moving to another slide, another board here. So add another page. Put some lines on here. If I can get enough toolbars out of the way. Oh goodness, I got a lot of chats. I haven't looked at them at all. Where am I? Stop sharing. Go back to sharing. This will work. Just enlarge it if I can. Nope. Let me. Okay, I remember the last one. 0, 2. And that was 0, 1, right? So that's the last step. But the one in between was this one, 0, 1 prime of t was what? E to the minus t minus, was it P01 of t? Or was there something in here? So I'm asking you if this equation is right. Wow, I'm waiting for you to answer. Let me see if I can get it myself. Oh, come on. No, it's not easy for me to get it myself. This thing does not cooperate. Ah. I'll try something else. There we go. Yeah, so it's this. P01 prime e to the minus this with a minus. That's the thing I want. Oh, so, okay, so go back to the page. And this is where we are. So we need to solve this. So to solve this, here's the steps. P0, well, let's call it y, just so we don't have to deal with this all the way through. So let y of t be equal to P01 of t. Then this equation looks like dy dt. I'll bring this to the other side, so that's plus y equals e to the minus t. This is what your book calls a linear first order differential equation. Oh, I need more room. Is it going to give me some? Yes, it will. Perfect. Okay. So how do you do this? You multiply through by what he calls an integrating factor. And I think in this case, it's just e to the t. So let's multiply everything through by e to the t. dy dt e to the t plus e to the t y equals e to the t e to the minus t. That's what integrating factors are for. They simplify this differential equation so you can solve it. Now, what if I did it right? This thing over here should be the derivative of the product of y and e to the t. Let's simply check. That's a product. So use the product rule. The derivative of the first function is this times the second plus the first function, which is y, times the derivative of e to the t, that's itself. So this is correct. And on the right side, you just have 1, right? So this trick of multiplying by this integrating factor turns this differential equation into one that's easy to do by integration. So if you just integrate both sides, on this side, when you integrate the derivative, you just get back to where you started. And over here, when you integrate 1 dt, you just get t. So integrating the derivative is just y e to the t, and over here, you just get t. So you can now solve for y. So y is equal to t e to the minus t. Just multiplying both sides by e to the minus t. Okay, and then remember what y is. Y was p01 of t. So this is p01 of t. Let's make sure it works. Good thing about differential equations, you can usually verify they work. So if you differentiate this, what do you get? P01 of t, the derivative of that would be the product rule here. So it would be the derivative of the first, which is e to the minus t, plus the first times the derivative of this, which is itself, with a minus coming through. Okay, but this, and if we bring this to the other side, then you just have t to the minus t, which is plus this. Equals e to the minus t. And that should be the original differential equation. Wherever it is. Yeah, that's this. The derivative of the function plus the function equals e to the minus t. Derivative of the function plus the function equals e to the minus t. So we've succeeded. We've succeeded in figuring out p01 of t. But in order to do that, we've had to learn or to use some differential equations, and we had to solve this linear system. And I did it by multiplying both sides by e to the t, which is what they call an integrating factor. If you don't want to go through that method, you can look in the book and they'll just give you the formula for this. Either one way or the other, you're using differential equations to do this. And our conclusion is what's in the box. Okay, so that's this. Now the last part of the game. The last part of the game was we wanted P02, and now we know what P01 is. So here's where we are. P02 of t, the derivative of that is P01 of t. And we just figured out that P01 of t is this. So put that in here. So that would be t e to the minus t. Okay, so now, well, let me stop here because we've done 2/3 of it. So there are two steps. We had to find P00T, and we did that using separation of variables. And the next step was to find P01 of T. And that was a little harder. We had to solve a linear, this is a linear constant coefficient differential equation. And the trick that works is multiplying this equation by e to the t, which is called an integrating factor. And then this becomes the derivative of the product. You can integrate both sides and solve for y, and you get your answer. So this is a solution method for a linear constant coefficient differential equation. Okay, so now the question is, okay, now we're at this place, which is what we were looking for to begin with. We're trying to find P02T without the prime. And from the forward equation, we know it satisfies this equation. And so now we need to know, so what's the program? You need to find the antiderivative of this, which is what you're after. And that amounts to finding the integral of this. The antiderivative of this is the integral of this. So it all comes down to integrating. So P02 of t would be found by integrating t e to the minus t dt. Okay. Well, you got to be a little bit careful. Yeah, the carefulness is coming in here. If you call this S, it's probably better. Because then you're integrating S e to the minus S ds. And then you could integrate from 0 to t. And that would give you the right variable over here. So when you integrate, there's the integration variable, and then there's the limits on it. And when you're all done, we want this to depend upon t, so we want that to be the upper limit of the integration. Okay. So how do you do this? Well, parts. This is from calculus. Parts is what? U dv is uv minus v du. And that's how you integrate something like this. This is sort of a typical integration by parts formula. So what to call u and what to call v. You sort of want to differentiate the s because that makes the integral you get over here easier. So you let u be equal to s, and you let dv be equal to what's left, e to the minus s ds. If you let u be s, then if you differentiate u with respect to s, you just get 1, and that tells you the u and ds are the same. On the other hand, if you have this, dv ds is e to the minus s. And so now to get what v is, you integrate this and you get v. And when you integrate this, you just get e to the minus s with a minus in front. It's easy enough to check. If you differentiate this with a minus in front, you do get this. Okay, so now we're set up for parts. So the left side just becomes u dv. The right side becomes u, but u is s. And v is this stuff. Minus the integral of v, which is this stuff again. And then du, but du is ds. And to actually get what we're trying to get out of this thing, we're really trying to integrate something that looked like this. So the limits on this are 0 to t. 0 to t here and 0 to t here. Okay. So this is the right trade. Why? Because over here, if you go one step back further, 0 to t, you're trying to integrate s e to the minus s ds. And we're saying you should do 0 to t of what did I just say, udv, yeah. So the trade is this integral for this one, and this one's easier to do, and that's why you use parts to trade a hard integral for an easier one. Okay, so doing this one, when you put in the upper limit here for s, you'll get this e to the minus t. And when you put in 0 for s, it'll all go away. So there's nothing to integrate here. It's not under an integral sign, so you're just evaluating it, and you get this. But this over here, the two minuses cancel, and you're integrating e to the minus s ds, not dt, from 0 to t. And if you do that, well, the antiderivative of this we already did along the way anyway. That just turns out to be, so this is minus t e to the minus t. The antiderivative of this turns out to be minus e to the minus s. Again, it's easy to check. If you differentiate this, you get that. And you're evaluating this between s equals 0 and s equal t. Okay. So let's see. When you put in t, you'll get minus t e to the minus s. And that's from this, or well, there's no t here. So what went wrong? I did something wrong. No, I'm evaluating t. That part's right. But when you evaluate this, you'll get minus e to the minus t. And when you put in 0, you'll get e to the 0, which is 1 minus, and then another minus from the lower limit. So you get something like this. Okay. So I think that's it. Yeah, that's this integral, and that's what this thing is. So if you want to write it with the positive term up front, it would be 1 minus e to the minus t minus t e to the minus t. So that's a pretty hard problem. Why? Because you have to solve a couple system of equations. And that's like almost everything we did in class. You have to do the separation of variable to get the first guy. You have to do the linear guy to get the second one. And then the last one isn't even a gimme. You got to do parts. But when you're all done, this is what you come up with. Could you check it? Sure. One way to check it would be to differentiate it and make sure it satisfies the equation you're after, which was which. Well, this one, right? So if you differentiate it, you should get that. If you differentiate one, it goes away. If you differentiate this, you'll just get e to the minus t. And if you differentiate this, I don't know what you get. But it's a product rule. Derivative of the t would just be this. Plus t times the derivative of this, which is e to the minus t with a minus in front. These cancel, and this gets you t e to the minus t. And T to the minus T is what you wanted. So it works. Okay. That's problem 5A. Problem 5B. God, didn't we do that earlier? It looks so similar. Let me go back. I thought we had this thing earlier. Oh, we did, but we didn't have ones everywhere. So this one, I don't know. Let's do that and then call it a night. Any questions on A before I move to B? I think B is one of the harder problems. Why? Because it's involving differential equations. A is one of the hard problems because it's involving differential equations. And, that's sort of a switch from what we've been doing all semester. But as soon as you have things like the forward or backward equations, then you're in the land of differential equations. So that's the other way to do these things. Questions before I flip the page? All right, so let's do one more. Go to dinner. Or maybe you already have gone to dinner, which I wouldn't blame you. Okay, so let's look at this one, 5B. So the picture is this. And the rates are all 1. And what do we want? We want P00T. Okay, so what's Q? It's a 3x3 matrix. You can go from 0 to 1, and that's all you can get to. From 1, you can go to 2. That's all you can get to, and from 2, you got to go back to 0. So that's how that looks. Two ways to think about it. One way is using, we have two approaches now, using our formula, using the eigenvalue expansion kind of thing. And the other way is just using differential equations. I think maybe we should try the differential equations, since so far we've only done one of those, and the more we do, we probably get better practice in. So let's just see what the differential equation looks like at least. So what's the differential equation you need here? It's the forward and backward equation. So P prime would be equal to Q P of T, which would be what? P of T cubed. All right, so I hate to be repetitive, but it seems like the forward equation has treated us well so far, so let's go with that. So P of T would look like what? P00, P01, P02. There are the others, P10, P11, P12, P20, P20, whoops, 21, P22. And Q would be this, -1, 1, 0, 0, -1, 1, and this is 1, 0, -1. And we're looking for P00, so that's the lead one, so that's looks reasonable. So that would be over here. So P00 prime, P01 prime, P02 prime, etc. Okay. So to find a formula for differential equations here, this is the one we're after. So it looks like P00 prime of t would be achieved if you multiply this row by this column. So it looks like you're going to get minus P00 of t. This times this is nothing. And then this times this is P02. Okay. So that's interesting. What's the problem? You need to know, in order to find P00, you need to sort of know P02. Oh, well, P02 is here as well. Let's see how to get that. To get P02, that's this one. You'd need to multiply this row by the last column. And that's going to be what? P01 of t minus what? P02. Okay, so this is sort of chasing our tail, because in order to find P00, we need to find P02. And to find P02, we need to find P01. We could write down the equation for P01 as well. P01 prime. That would be the middle one. And you'd find that by multiplying this times this. So that would be P00 t. Let me see if I buy that. Yeah, P00 t times that minus what? P01 of t times that. Okay. So I think if you're trying to get any of the derivatives in the first row of the P of t matrix, the equations look like these. That's a little discouraging, because you don't know any of these at this point. Yeah, I'm looking at it to see if there's a nice, easy way out of this mess. Let me see. I think there's a way out, but I'm not sure it's a way that we've talked about in class. So let me see if there's another way to go. Give me a second here. Zero to one. Well, let's try our other method. I'm not excited about it, but I'm not excited about it because I don't think it came up in class yet. But at this point, I think it may be a way to go. So this is our differential equation method. If we just go back to the differential equations, if we want to find P00, which is what they're asking, this would be a start. Yeah, I'm still trying to think if I can make this work. Maybe. But I'm not going to take more time. Let me try our other method because we have two methods. So our other method is what? Our other method is we just go for all of them. If you go for all of them, then it's going to be what? A1 e to the omega 1 t plus A2. It's the linear algebraic method. A3 e to the omega 3t. And what do we know? We know that there always will be an eigenvalue of 0, so we might as well call it omega 3. And that makes this. Okay, so this comes down to finding the eigenvalues. And this will be fine. This will be interesting, but I don't think it's something we've done. Find the eigenvalues of Q. Okay, I'll let you do that on the calculator and tell me what you got. I'm looking at who survived this session so far. It's a long one.
I got it. And I don't know if it's right because I got like complex eigenvalues.
It's right. It's right. Okay, I'm not sure that's intended for me, but whatever.
No, sorry, it's my cat.
No sweat. So give me your eigenvalues. They're complex, you told me.
So for the first one, I got -3/2 plus I square root of 3/2. And then, yeah, for the other one, it's just the opposite.
With a minus, you're saying?
Yeah.
Okay, so this might be your omega 1, and this might be your omega 2.
Yeah.
Okay. Okay, now why I'm smiling is evidently I got a little further, or when I taught this one time, because I don't think this has come up in our class. But these are correct. Your eigenvalues are correct. So eigenvalues don't have to be real, they could be complex. Okay. Well, all right. Are they distinct? Yeah, they are. I mean, 0 is not like either of these. You should have also gotten 0, right? For sure. But these guys are all distinct. So let's call this one omega 1, call this one omega 2. So what does it say? It says P of t can be written as A1 times e to the -3/2 plus I radical 3/2 plus A2. Oh, there's a t in there too. minus 3/2 minus I square root of 3/2 t plus just A3. Okay, so the question becomes, how do you deal with complex eigenvalues? The answer is you pretty much just go with them. Let me see if there's anything that I need to tell you here. I assume that this other class got to this point because that's in here. Your class didn't get to it. And I'm trying to think, so I'm trying to think two things. One, is there anything that I need to tell you how to make this work? And I have a feeling it works just the way it always did. As far as what we've been doing. What does that mean? That means if you set t equal to 0, this still becomes the identity. By our initial values. And this still becomes e to the 0, which is gone. And so you get A1 and A2 and A3. And if you differentiate, what happens? If you differentiate, you get A, and then, but here's the new twist, I guess. These things stay the same. But then what comes down is the complex eigenvalue when you take the derivative. When you take a derivative of an exponential to this complex exponent, this thing comes down, minus 3/2 plus I, what did you say, square root of 3/2 plus, that's still A1, and this is still A2, and you get the same eigenvalue stuff here. But what comes down is this thing when you differentiate. And the constant still goes away. And if you set t equal to 0, over here you still get q. And over here you get A1 times this complex number. Plus A2 times the other complex number, minus 3/2 minus I square root of 3/2. So everything still works the way it did before, except you're in complex numbers. So assuming that's going to carry, what's the next one? You could guess. Q squared is going to be what? A1 times this thing squared. Plus A2 times this thing squared. Okay, so you still have the same three equations that we've been having all along. Just the twist is you've got these complex variables. Okay. Could you still go forward the same way? I think so. I think you can figure out. So what are we after? We're after the A's, A1, A2, and A3. And I think you can solve them as we've done in the past. Now let's see if there's an easy way here. Well, this one we usually leave to the end. But this one, for instance, we could solve for A2. We can swing, well, A2 or A1, it doesn't matter, but let's go for A2. You can swing this one to the left side and divide by this complex number and get A2 in terms of A1 and Q and other things. And then you can substitute that into here and solve for A1. So I think you can proceed the same way is what I'm suggesting and figure out what A1 and A2 and A3 are. whoops, yeah, A1, A2, and A3. But what's the change? The change is you got complex eigenvalues. When you do all of that, suppose you do all of that, then how would you get P00 of T? If you know that P, go back to what we had. This equation here. Well, that's when we were trying to use differential equations. But if you go up to this equation here, suppose you know what the A's are. They may have complex numbers in them, but you know what they are. Then what do you want over here? This guy is a 3x3 matrix, which I think wrote down somewhere. I don't know. Maybe I've written it. Yeah, it's up here. And you want this entry over here. And well, except in this case, you don't want the prime. So the entry you would want would be the P00 entry. And it would be what? It would be what's in the upper left-hand corner of A1 times this. Then what's in the upper left-hand corner of A2 times this. And then what's in the upper left-hand corner of A3. So I'm really just telling you everything's the same. However, something nice should happen. I'm not sure I'm going to do it now, but I'll just tell you what nice should happen. Because P00T is real, right? Because this is the probability of getting from 0 to 0 in time t. So even though it's represented as, you know, what's in the upper left-hand corner of this times this, and the upper left-hand corner of this times this, plus the upper left-hand corner of this, when you combine all those things, it should turn into a real number, which is really cool. Why is it really cool? Because to find probabilities in this case, using the method that we've been using, or at least this method of it, you have to go into complex variables or a complex plane. Well, it's almost 7, so I don't think I'm going to press it. I have to think twice whether we should do this in the class or not. And I think I've already told you this is the last new material. But it's sort of a hard one. Why? Because the method still works. Everything still works as long as you can, as long as you don't freak out over complex eigenvalues or complex numbers coming into the game. So try what I just said. Try to figure out the A's in the same way that we've done a few times tonight, right? You don't need all the A's. All you really need is in what's in the upper left-hand corner of each of them, right? But I think you need to get the formula for the A's to do that. I'll give you another little hint. I think A3 turns out just to be real. And these will have complex numbers in them. But when you put in, yeah, as I say, they should cancel so that what you come out with as an answer should be real. Okay, so there's two ways. There's this way, which I've just described using the method that we've used a few times tonight, but it has a twist. You need complex eigenvalues. The alternative is to try to make this work, and I'll think about that later. Can we make that work? Maybe. Maybe, because why? Let's see, if you're going from 0 to 2, here's a way to make this work if you really want to try. Going from 0 to 2 in time t should be the same as going from where? 1 to 0 in time t? And that should be the same as going from where? 2 to time 1 in time t? Why? Just by the symmetry of the diagram. Go back and look at the diagram. the chance of going from 0 to 2 in time t should be the same as going from 1 to 0 in time t. Why? Because the diagram is symmetric, right? In either case, you've got to go 2 steps up and finish here in time t. And if you started here, you'd have to go 2 steps up and finish in time t. So what I'm suggesting is, and by the way, the same works for going just 1 step up. If you want to go from 1 to 2 in time t, that should be the same function as going from 2 to 0 in time t, and that should be the same function as going from 0 to 1 in time t. So what am I describing in here? A lot of these functions are the same. And maybe that can make solving this system much easier than it first appears. That's what I'm going to be thinking about. You follow the suggestion though? This is a symmetric diagram. So going from here to here in time t should be the same probability as going from here to here in time t. Why? There's nothing to distinguish it. The rates are the same. The trip is the same. You're just taking, you know, where you go, you might have gone around 3 times to do it and get from here to here, but the same thing is possible going from here to there. So I'm saying a lot of these functions are really the same functions in disguise. Like which of them? I think everything on the diagonal is the same function. The more I talk about it. Going from 0 to 0 in time t is going to be the same as going from 1 to 1 in time t. Is going to be the same as going from 2 to 2 in time t. So those are all the same function. 0 to 1 and 1 to 2, I already said, are the same. And 2 to 0 are the same. So these 2 and this are the same function. And what's left? Going up by 2 steps, right? And those are all the same. So even though this looks like it has 9 different probability functions, it really has only 3 different kinds. And maybe that means I can simplify these equations and solve them more easily than it first appears. Anyway, so I've given you 2 things to think about. Complex eigenvalues here, or using the symmetry of the diagram to say that a lot of these functions are the same. And maybe that'll make this system of equations easier to solve. Maybe. Have to think about it. Hey, thanks for hanging with me. It's a long session. Any quick questions?
I have a question.
Sure.
For the final, is it gonna, are the questions gonna be this intense and like, I guess, long? That's really what I'm asking.
The answer is probably. Why? Well, this was what the final was for people. What was it? I don't know what the date is on this, but the last time around. Yeah. So I mean, that's sort of why I give you the test and help you get ready for it. Now, some of them are harder than others. Okay, so they're not all equally difficult. But it's a good thing that we're going through it. I mean, this one on number 5B, for instance, or even 5A. 5 is an interesting question because you're using differential equations, right? And I don't think before that we've used the differential equations that much. But yeah, no, this is fair game because I'm giving you the past test, right? So what giving you the past test should mean what? If you see problems that look like this on this test, on your test, at least you've seen them before. Hopefully you have wrestled with them a little bit. Well, I mean, I could ask a question back. Now that we've gone through 4 or 5 of these problems, could you do them? If I gave you the same test, could you do it? Could you do 3 out of 5, for example? You don't have to get every problem right.
Professor, I was actually going to ask a question too.
Oh, wait, I want
related.
an answer to my question. Okay.
What?
If
well-
I give you the same test, could you do 3 out of 5 now?
I think if with a little bit of like going over like the weekends and stuff like that, I'm sure I could do them. I'm just not sure if I could do it within the time that we have. Cause you said that we would also be working with a shorter time frame for this final, right? Because of your
Yeah, but the shorter time frame turns out to be 10:30 to 10:30 to 2:30, which is still 4 hours, right?
guess
Isn't it
that's
right?
true.
Yeah.
I was just
so-
concerned since this review I guess the review should be longer than what the test should be, but
Yeah. Oh, the
was my
review. Yeah, no, I admit this stuff is not easy. But some of it's easier than others. Okay, so for finding the stationary distribution, which was what? 2, I think, I forgot which one that was. I think you did it in 2 places. Find the steady state, we did that on problem 2. And I don't know if it was somewhere else. Some of those things are easier. But yeah, no, this is not, it's not simple. It's long stuff. I admit that. Which is what I told you the first day. I want to give you time so that the time is not an issue. But go ahead. What was your other question? Or maybe
No,
it
it was
was
just
that.
about this, about like I
Yeah.
guess more of a concern whether I have enough time. But I think if I go over the weekends and stuff, it should be fine. Like you said, it's still
That's-
4 hours. So
Yeah, if you think of it, if you think of the 2 tests I think we've done, they've been what? 4 out of 5 problems, something like that. So if you get another 4 out of 5 problems, even if a problem takes 45 minutes each one, if you have like 4 hours, you should be able to do 3 or 4 of them. The things I worry about are, I'll tell you what I worry about is that people don't have their calculators geared up. So if you can't find eigenvalues, you're really hurting.
I'm one of those people, but the matrices haven't been that bad to where I can't do them by hand.
Oh, no,
So-
no, but that's, now you're going to pull my hair out, okay? Because I don't want you to do it by hand. I want you to do it by calculator. It should be like 3 minutes or something. I don't want you to, I don't want, look, I'm in sympathy with you. You won't have enough time if you got to do everything by hand. That's a concern. So you just don't have a calculator that does eigenvalues? Is that where you're at?
I tried to do it and I tried looking up online, and for some reason I'm just not getting the right values, or it's just not working. So I just resorted to doing it by hand. So it's not too bad, like you said, because we mostly do 3x3s, and then the 3x3 reduces to like basically just 2. So like it hasn't been that much trouble. But if it were like, I guess, a 4x4, then I probably, if most of the entries weren't zeros, then it'd probably be a bigger issue.
Yeah, which means you'd skip that problem, which is probably not what you want to do. Let me make a suggestion in that way. Do you have, so your calculator, you're not able to find eigenvalues using your calculator. Is that what where you're at?
I'm sure there's a way. I just haven't been able to do it.
No, you haven't been able to do it. What kind of calculator do you have?
I have the TI-84.
Okay, do you know anyone who has an 89? Because it
No,
seems-
I do not.
Yeah, well, okay, here's an alternative. Go to the department. Are you ever on campus? I don't know if you're ever
Yeah,
on
I
campus.
can go on to campus. That would be
Okay, okay, I don't want to put you in a place you don't want to be, but as long as you're not uncomfortable going to campus, go to the department. Tell them that I asked, I sent you. I think you'll be able to check out a TA 89 or some calculator there that will do the eigenvalues. And you could do that, tomorrow if you want. I mean,
Okay.
and if it doesn't work, if they say, if they give you a hard time, just give me a call or shoot me an email. But I've checked out calculators for students in the past. Okay. In fact, by the way, ironically, I have a student who's just trying to return a calculator to me. So maybe I should hook you up with that student. But yeah, I mean, that's the part that worries me. That's where you're using time that I don't intend you to waste. Okay, I don't mind if you're thinking, but I really don't want you to be trying to figure out how to get eigenvalues during the test. I want that to be like, oh, here's the matrix, enter the matrix, push the button, there's the eigenvalue. That should be automatic. So and I'm not just talking to you, I'm talking to who's ever here listening still. I don't think you want to spend time fighting your calculator on the test. The calculator is supposed to be an aid, and I don't want it to be a decider. So God forbid if I give you a 4x4, that way, I mean, it may turn out to be okay. He gave me a 4x4, so I just worry about the other problems. And that could turn out okay, but that's certainly not what I intend. I mean, I had one on the other test. I had 7x7 that was doubly stochastic, right?
Mm.
I don't know if you did okay on that,
Yeah.
but if and I think on that one I asked people to find the stationary distribution, and if you didn't recognize it being a doubly stochastic, well, you could still use the algorithm, right? There were some people who did that and still got it because they still had the algorithm and they could use their calculator. But if it were you and your calculator wasn't working, and you can't use the algorithm on the calculator and you didn't recognize it was doubly stochastic, I would feel bad for you because there's two ways for you to still get that problem. One is with the calculator and one is recognizing it to be doubly stochastic. And if the calculator is not one of your alternatives, that cuts your chances of doing well on that problem down, which is not what I intended. So yeah. I mean, if there's other ways to save time, I'm certainly open to saving time. I mean, the other alternative is just to let you use Wolfram or something like that. But that's no good either unless you really know what you're doing on Wolfram.
I think I'll be okay. I'll figure out the thing with the calculator because I'm sure there's a way. I just need to like sit down with it, and as I'm going like through the weekend, I'm sure I can figure something out. Because I'm almost positive the calculator can do it. I just need to know how to put everything in there.
Well, yeah, I would be more encouraging if I remember people in class doing it with the 84. I know people were nailing it with the 89, but I don't remember anyone. Was there anyone in there who had an 84 that was really getting the eigenvalues? I don't recall that.
I think there was something 84, but I think they were having the same trouble I was.
Yeah, so that's hardly encouraging. So anyway, keep in mind what I'm saying. Maybe you can get an 89 from the department, okay? If you just go in there and say, Krennic sent me, can I borrow an 89 just for my upcoming test? And they're pretty friendly, I think, overall. I think they'll probably ask you for your car keys or I don't know what some collateral or something, but I'm teasing. No, they'll probably want to know your student ID number or something. But I think they'll probably be able to help you. So think about doing that. All right. Any other questions? All right.
I have to let you know if we want to start at 10:30.
No,
Oh, okay.
no, just show. Yeah, I'm going to send out the usual invitation to everyone at 10:30, and those who appear I'll start you out then, and those who don't, I'll start you out whenever you come. So, yeah, I'm a little worried about time too because I don't like calling time on people. We'll see. All right, I'll see you in class tomorrow.
I'll see you tomorrow too.
See you tomorrow.
Yeah, thanks for coming tonight or today. Turned into tonight. Think about this last one. I'll be thinking about it too.
Okay.
Bye.